Welcome all of you in this session. Chairman Dr. Ravi Shankar, have you joined? I think our chairman has not yet joined. Dr. Shen, can we start our this session because chairman has not yet joined?
I'd love to introduce the chairman and the speaker also. Anyway, let me start.
Okay, then I'll request you to chair this session. I welcome all of you in this plenum lecture. Today's plenum lecture will be delivered by Professor N.H. Rabindranath. He's a retired professor at Indian Institute of Science, Bangalore, India. Professor Rabindranath has focused his research, advocacy, and publications on various dimensions of climate change, mitigation assessment, greenhouse gas emission inventory in land use sectors, impact of climate change, and vulnerability assessment in the forest and agroecosystems. Adaptation and climate resilience, forest ecology, CDM, and REDD plus projects. He has also worked on bioenergy, biofuels, and biomass production, environmental and ecosystem services, and citizen science. He is an author of for several IPCC assessment report on climate change of WMO, UNEP, focusing on mitigation in forest sector. He is an author of intergovernment platform on biodiversity and ecosystem services reports. He is the scientific advisory panel member from Global Environment Outlook. He was the science technology advisory panel member of JIP, that is Global Environment Facility for Climate Change Focal Area during 2008 to 2012. He is the UNICEF expert reviewer for greenhouse gas inventory reports, is a member of Science Policy Initiative Expert Committee of UNCCD. He is a member of Scientific Advisory Panel of UNEP Global Environment Outlook 6. He has published and books from Oxford and Cambridge University and Springer publication, out of which 4 are on climate change. He has published over 150 peer-reviewed research papers, out of which about 60 are on climate change. He has worked for advised many state governments on assessment of climate change projections, impact, and vulnerability. He is an expert for several World Bank, UN, and other bilateral projects related to climate change. He was on the editorial board of several top international journals, such as Environmental Research Letters, Biomass and Bioenergy, IITI journal, MITI journals, etc. A study conducted by Stanford University recognized Professor Rabindranath as one among the 2% of the world most cited researchers. Now I invite Dr. Professor N.H. Rabindranath for delivering his talk on the topic natural ecosystem, biodiversity, and climate change. Thank you, sir.
Thank you, Chair, and I'm very happy to be here and participate in the workshop, this international workshop. I request the host to upload my presentation. Is it Ramya? Please upload the presentation. Well, I'll talk about the natural ecosystems and biodiversity and climate change. We all know natural ecosystems and biodiversity are interlinked to one another, and climate change will impact biodiversity and ecosystem services. Professor Sain, somebody would upload my presentation, please.
Yes.
Yeah, sir. Yes.
Yeah, okay. So, in the meanwhile, I will continue because it's only half an hour. Well, I will talk about projected climate change very briefly. You all know climate change is already happening and it will continue to happen. And I will briefly talk about the observed impact of climate change because very often, at least in the government till recently, even now, some people think climate change is something which is different thing. It's about 30 years, 50 years, 100 years. But actually, there is so much scientific evidence, as brought out by IPCC and IPBES, that climate change is already happening and it's impacting natural ecosystems and biodiversity. And thirdly, I want to talk about projected impacts of climate change on natural ecosystems and biodiversity. And finally, I will talk about the strategies to manage the adverse impacts of climate change and biodiversity. So I
Sir,
hope.
can I request, sir, can you share from your side, because I are facing some technical problem on uploading your presentation from this side.
Okay, I will try.
Yeah. Yes, sir, it is coming here.
Okay, fine. Thank you.
Thank you, sir.
Okay. So I was talking about the outline of our presentation, but we all know that climate change and biodiversity has global concerns. It's not just concern of one country or one region or one type of ecosystem, but both biodiversity and climate change are global concerns. And science is evolving so quickly in the last few decades that United Nations set up international bodies to assess science and present it to policymakers. One, of course, you all know about IPCC. It has already brought out 5 assessment reports, and the 6th one is currently in the process, and later this year, reports will be released. So I've been an author for many IPCC reports. And second is Intergovernmental Platform on Biodiversity and Ecosystem Services. Just like UNFCCC is for climate change, there is CBD for biodiversity. And they also bring out periodic assessments of biodiversity and ecosystem services in the context of human welfare. So, and thirdly, Global Biodiversity Outlook. Again, CBD periodically brings out biodiversity outlook in the context of commitments made under CBD. And UNEP, UN Environmental Program, also brings about global environmental outlook periodically. You see, IPCC, that's again the 6th report is out recently, and there's a global wetland outlook. That means there is so much global level concern and interest among the scientific community and among the policy community. I think if you look at all the different aspects, dimensions of science, climate change and biodiversity have attracted a lot of attention of policymakers. Even the prime ministers go periodically to New York and many other places to talk about climate change. That's the level of importance. Next,
sir, kindly put your presentation in full screen mode, sir, please. Yeah, thank you.
Okay. Sorry. We all know the Earth has warmed, and in fact, IPCC set up. The UNFCCC requested IPCC to come up with a special report on what's called 1.5 degree. What will happen? Because under the Paris Agreement, there is a global agreement to hold global warming.
Anything.
You can't hear? Yeah, I think, see the...
We are able to hear you.
Any problem?
We are hearing you.
No, it's okay, sir.
No, sir.
Yeah.
It's fine.
Okay, thank you. We all know that Earth has already warmed, and we know that 1.5 degrees is one of the globally accepted dangerous thresholds. But if you look at the observed temperature trends, the Earth has already warmed by more than 1 degree, and dry land ecosystems have warmed by 1.2 degree, and the intensity and of frequency of all climatic extremes such as drought, floods, forest fires, cyclones have been increasing. We heard about the extensive forest fire which destroyed 10 million hectares in Australia in 2019, and in 2020 we had a unprecedented forest fire in California and many other parts of the world. There have been floods, unprecedented floods in different parts of the world. So there's a lot of things happening, and all of them have been significantly linked to the ongoing climate change. And rainfall patterns, of course, we all know as agriculture scientists and fishery scientists, we all know rainfall trends have been changing all over the country. And I will briefly talk about the projected climate change. And given the audience is largely Indian, so there is a global assessment under the WMO called CMIP. It's again a coordinated, integrated modeling project, because there are some 40 to 60 groups working on making projections of climate change. There are global protocols and accepted, and based on that, CORDEX, regional again coordinated program, where for the South Asian region, 50 kilometer climate change projections have been made and presented by IITM. It's called the CORDEX experiment. CORDEX outputs are available based on CMIP 5. Soon CMIP 6 will become available, maybe by the end of this year. And according to that, most parts of India and globally, it will warm by 1.5 to 2 degrees even in the next, before 2040. Even by 2035, some parts of India could experience warming up to 2 degrees. And if you look at rainfall, consistently all the models, in fact IITM CORDEX experiment includes 14 or 15 models. All of them show there will be increase in rainfall in most parts of India, even in the short term of by 2030 to 2040. By 2070 to 2100, the intensity will be even higher, the increase in rainfall. So increase in rainfall, we all know, is as bad as more damaging than decline in rainfall, because it leads to damage to ecosystems, property, crops and livestock and so on and so forth. So we have to brace for not only warming on the one hand, the natural ecosystems and agriculture and other human systems will have to brace for changing in rainfall pattern as well. Temperature, humans can cope with whatever level of warming you can think of. People have been living from minus 50 degrees to plus 50 degrees on Earth, but crops and ecosystems are sensitive to even 1 to 2 degree warming or even decline in temperature. So, but rainfall changes, especially increase in intensity of rainfall, increase in rainfall will be very damaging for many ecosystems as well as human society. And let's look at the impact of observed climate change. As I was mentioning, very often, I used to go to Delhi. I've gone maybe hundreds of times to attend meetings. Policymakers in Delhi used to talk about climate change as being, it's away 2050, 2100. It's not an issue now, but there is so much scientific evidence. Literally, there are hundreds or thousands of papers published in international literature on how climate change in the last few decades is impacting ecosystems, biodiversity, and many ecosystem functions and ecosystem services. In fact, climate change is already a direct driver. On the one hand, it's changing many ecosystems, and it's an indirect driver in the sense it exacerbates the impact of other environmental degradation components. Science has shown that degraded ecosystems are more vulnerable to climate change than pristine, undisturbed ecosystems. So climate change has contributed to widespread impacts in many aspects of biodiversity. For example, changes in species distribution, phenology, population dynamics, community structure, and delivery of many ecosystem services. And again, according to published studies, the effects are accelerating in marine ecosystems, terrestrial ecosystems, as well as freshwater ecosystems. All ecosystems are vulnerable to ongoing climate change. We are not even talking about future climate change. It will be even more severe. Even the abundance of native species in major biomes and ecosystems are declining. Again, there are shifts in species distribution and many other changes in phenology, ecosystem functions, ecosystem services have changed. It is all based on scientific evidence and published papers. It's not any just modeling, it's observed. And again, population sizes of wild vertebrate species have tended to decline. Again, global trends in insect population also seem to be declining. So there is massive scientific evidence published by IPCC, Intergovernmental Climate Change, and IP-based intergovernmental platform on biodiversity and ecosystem services, and many ecosystems, freshwater, terrestrial, and marine, have experienced, even species extinctions. In fact, they have been attributed to the ongoing climate change already. In fact, we have to wait for the future decades about what will happen to species extinction. And numerous observations published in the last decades also show ocean basins show significant changes, in the abundance distribution and shifts. In fact, there are studies by CMFRI have shown that some of the species are shifting towards warmer climate in the oceans. So it will have an impact on availability of fish catch also. Again, we all know that corals and the reefs have been responded. It's very well recorded. There's so much literature on even in National Geographic and so on, how the coral reefs have been impacted. That's very well known. And in addition to climate change, simply elevation of CO2 concentration in the atmosphere is leading to ocean acidification. Ocean is becoming more acidic, and many countries are most worried about the impact of even ocean acidification due to elevated CO2, which will impact fish and many other commercially important species as well. Again, we all know all the coastal ecosystems and the oceans have been exposed to unprecedented anthropogenic climate change, as well as pollution and many other environmentally degrading aspects. And again, the impacts of recent extreme events have shown how ecosystems as well as human society is vulnerable to drought, floods, cyclones, hurricanes, and even extreme heat stress events around the world. And let me briefly talk about the impact of projected climate change. You can talk about the impact of climate change on wetlands and on oceans and freshwater ecosystems and agriculture and forests and so on and so forth. You need several hours. There's a huge chapter for each of the ecosystems in the IPCC reports. And IPCC also provides some sort of an overview of the impact, how even every 0.5 degree warming, 1 to 1.5, 1.5 to 2, 2 to 3, 3 to 4, how it will impact various ecosystems and various, again, production systems around the world. There is a nice diagram which summarizes, for example, how dryland water scarcity, how it will become worse at 1 degree, 1.5 degrees, 2 degrees, 2.5, and so on. So it shows that even by 2 degree warming, we are already close to 1.5, but 2 degree it will become highly vulnerable, all fresh dryland ecosystems. Soil erosion would get enhanced, vegetation loss, again, even at 1.5 to 2 degrees, it's significant vegetation loss is projected. Wildlife damage, even at 1.5 degree. We have seen in Australia, in California, to many other in Europe, how wildfires are damaging ecosystems and even human settlements. Permafrost degradation, it's very vulnerable even below 1.5 degree. Similarly, tropical crop decline and many other ecosystems are highly vulnerable even to a warming of 1 to 1.5 degree. So that every half a degree warming, the impacts get multiplied. Again, there's another graph from IPCC recently. It shows how corals will be impacted even at 1 degree. We have seen, with wonderful films from National Geographic and many other agencies, how even now at 1 degree warming, how corals have been impacted. Mangroves, they seem to be a little more robust compared to other ecosystems. Small scale, low altitude, latitude fisheries are vulnerable even at 1 degree. You can see there's already dark red color. Arctic region, terrestrial ecosystems, coastal flooding, fluvial flooding, crop yields, tourism, and many other other ecosystem functions and economic benefits will be impacted even by 1.5 to 2 degree warming, to which we are already exposed in our own lifetime. Even someone like us, a retired professor, will see these impacts in our own lifetime, and we are not even talking about our children and great grandchildren and so on. Projected impacts, of course, climate change is becoming increasingly a direct driver of climate change, and it also accelerates the impacts of other degrading drivers. And the adverse impacts of climate change, biodiversity are projected to increase at every, as I mentioned, at every half a degree warming of it's been shown. And even at warming of 1.5 to 2 degree, majority of the terrestrial species are projected to the spread is projected to shrink. In fact, they will start moving towards higher latitudes from Himalayas or even from Western Ghats and so on. So again, large number of studies have shown that significant fraction of the known biodiversity is under risk. In fact, there is one of the headline study when IPBES report was released last year was 1 million species are under threat of extinction by climate change and other degrading interventions and human impacts. 1 million species under threat. That was the headline last year. And again, we all know about the coral reefs and how vulnerable they are already, and it will become even more in the coming decades. Climate change alone is projected to decrease ocean net primary productivity, and climate change and business as usual fishing scenarios are expected to worsen, including its impact on biodiversity. So again, climate change alone is projected to decrease ocean net NPP significantly. So therefore, there are enough scenarios, scientific modeling studies for future, observed studies for the last few decades, which show that even a 1 degree warming, a 1.5 degree warming, or 2 degree warming are significant. They will impact. They're already having impact. They will have an increasing level of impact on biodiversity and ecosystem services in the coming decades. So, well, obviously, the very purpose of setting up IPCC or IPBES and many other international bodies is to come up with many options. IPCC, IPBES and others, they don't recommend to the policymakers you do this. They only give different options and the implications of that to address climate change, to address biodiversity loss, to address ocean acidification and so on and so forth. Of course, there are some broader issues and there are some specific issues. Of course, reducing socioeconomic pressure, land use and pollution and the spread of invasive species is very critical, because as I mentioned earlier, degraded ecosystems are more vulnerable to climate change than pristine or undisturbed ecosystems. So we need to make sure that our ecosystems are not burdened with invasive species, making them more vulnerable, or land use change, pollution, all of them make ecosystems more vulnerable to climate change. That means we need to reduce all the socioeconomic and pressures on all natural ecosystems. And again, adoption of sustainable extraction and management practices of forests, ocean, wetlands, croplands. We all know how fisheries are being overexploited. In fact, there was a study just a few days ago published in Nature. It hit headlines saying how mechanized boating is leading to such a irreversible damage, not only damage to fisheries but also to global climate change. And again, adaptation, conservation, all of them are location specific. We all know, all scientists know that all adaptation or resilience building measures are context specific, location specific. We need to know local communities, and again, we need to adopt conservation measures for biodiversity and ecosystem services at a location specific level. Whereas for mitigation, like improving energy efficiency, it's global. If you take air conditioners, they're same around the world. If you talk about energy efficient bulbs, they're same around the world. But when it comes to adaptation and resilience building measures, they vary from location to location. Of course, overall, we need to reduce CO2 emissions, not only for address climate change, but also ocean acidification. We all know many are more worried about ocean acidification than climate change, especially fisheries experts. And again, all these UN reports, IPCC, IPBES, UNEP, and Ramsar Convention, they all talk about we need to talk about transformational change. Small incremental change will not address biodiversity or climate change threats for the world. We need to talk about some sort of a transformational change in of how land and forests are managed. We need to conserve all the existing intact ecosystems and restore the degraded ecosystems and reduce the pressure on the ecosystems. And of course, we need to plan at a landscape level or a ecosystem level rather than certain active actions can take place at a village or at a micro level, but some actions have to take place at a larger scale. And again, we need to think of sustainable freshwater transition. Again, how to ensure continuous freshwater flow into different ecosystems, and again how to safeguard connectivity to allow recovery of freshwater ecosystems, and in the mountains, and again sustainable fisheries and ocean transition. I don't You all know much more than me. Sustainable agriculture, we need to really transform agriculture so that it's based more on ecological principles. And we all know how biodiversity is very important even for sustaining food production in the coming decades. And again, sustainable food production transition. We all know that 25 to 30% of food produced is wasted either at the farm level or after it's packaged and sold. In fact, many in Europe there are studies to show almost 40% of the food bought from supermarkets is thrown away. So imagine how much energy, water is used to produce this food. All that is thrown away. So we need to really how we can improve the diet. Everyone knows that meat consumes a lot of water, a lot of energy, leads to a lot of CO2 emissions than plant-based diets, apart from being good for health, good for heart and other diseases. So there is a need for improved diet and reducing the waste so that you reduce the pressure on land and water and other ecosystems. Of course, climate action, we talked about it, and it's very important for its own sake as well as for biodiversity and human health and food production and water availability and so on and so forth. Again, biodiversity and health transition. We all know how the current pandemic is linked in some way to loss of biodiversity and human intervention in biodiversity, interaction with natural wildlife and so on. So even biodiversity conservation is important even for health. So I don't need to stress more how important we should look at managing water sustainably, managing oceans, agriculture, and of course addressing climate change. And again, at a global level, of course, as I mentioned, climate change, biodiversity are global threats, global concerns, and they have to be addressed globally. Just India alone cannot address any of these problems. China alone cannot. United States cannot alone address any of these problems. You need a global action. That's the reason why we have all these climate change COP meetings, biodiversity COP meetings every year. In fact, the next one is in Glasgow in Scotland in November, December this year, which was postponed from last year because of the pandemic. If you look at broadly, then you have Paris Agreement, you have Sustainable Development Goals, you have biodiversity targets, you have Ramsar Convention, you have Land Degradation Convention. There are a number of global conventions. Government of India, all the governments have signed on to that. Even United States, which had withdrawn from Paris Agreement, has rejoined Paris Agreement. So we need to really, if you address Sustainable Development Goals, you'll be addressing climate change, you'll be addressing biodiversity loss, you'll be addressing many other ecosystem concerns. In the same way, there's a direct link between addressing biodiversity, addressing climate change, addressing sustainable agriculture, and so on and so forth. So that means there is a global interest, and in fact, every time recently G20, there was a meeting of G20 where even Prime Minister Modi talked about how India will contribute much more in addressing climate change. Even Biden, US president, first thing he talked about, first day he became president, he rejoined Paris Agreement. He said he will do everything to address climate change. That means at a global level, there is a huge appreciation and concern about climate change, biodiversity, ocean acidification, and so on, other threats. And I'm sure scientific community is working, scientists are working on pandemic around the clock. I'm sure scientists are working around the clock to address this climate change. At least for COVID-19, there is a vaccine. You can come up with a vaccine in a few months. But as I say, for climate change, there is no vaccine. There is no single silver bullet. We need to address agriculture sector. We need to address energy sector. We need to address transport. We need to address fisheries. We need solutions in all aspects, in all sectors, and on all continents. So with this, I thank the organizers for giving this opportunity. I really admire, even during pandemic, such a large international workshop being organized, and Professor Sen and all his colleagues. I thank them and wish them all the best. Thank you very much.
Thank you very much, sir. Now I request Chairman for his remarks.
Professor Ravindranath,
Yes, sir.
uh, you have been quite vocal about the climate change adaptation and mitigation policies being undertaken in India in particular, uh, as per the Paris Agreement. So, do you think that India is going in the right direction?
Well, I'm sure just a couple of weeks ago, Prime Minister himself spoke at G20. It's on the YouTube also. You can see he promised that he would do much more than what India has already committed under NDC, and India is going in the right direction. But I agree, there's a lot more to be done. It's never enough. But if you look at adaptation and resilience building measures, research in ICR, I would say ICR is the only agency to some extent under NICRA and other programs, some activities happening. But whereas in other ecosystems, other sectors, not much research is happening. I'm talking about natural ecosystems, and I'm not talking about energy and so on. But there's a need for a lot of research in agriculture, forests, wetlands, oceans, freshwater ecosystems. A lot of work is required in India.
The huge task, in fact. Well,
Yes.
a huge task is required, and that too in coordination with all other nations. India cannot do anything alone, or for that matter, no country can do it alone. Thank you very much. I think it's time now. We have to close at 2:30 for the next session to start. And if you have any one question from any of you, kindly ask for a crisp answer. Please, Dr. Taggi.
Yeah. Well, Professor Ravindranath has given a very comprehensive presentation of the global situation. As we know from the 9 planetary boundary paper, long time back, I think 2011, the global picture of the different planetary boundaries in terms of biodiversity, in terms of nitrogen flow to the rivers, and in terms of coal, it is given there. Do we have some India-specific information on these planetary boundaries that are being violated due to climate change?
No, unfortunately, no. But I'm fully familiar with all the climate changes in India, and I would say we are in infancy. We're at the beginning of learning. We have to do a lot. To some extent, I admire ICR for launching NICRA. To some extent, it has done a lot of work, but again, a lot more work is required in other ecosystems.
Thank you very much, Professor Ravindranath.
Thank you, Professor.
For your excellent presentation, and we have learned quite a lot from your lecture, and we keep on learning. In fact, that's true, and this is not a subject that you can learn overnight, and we have to do a lot of experiments, achieve different target goals, and then try to ascertain how quickly we can monitor and achieve that goal. Thank you very much, Professor Shanalo. I think it's time now for the next session to start. If you can kindly excuse us for that. Thank you very much, Professor Ravindranath, on behalf of the organizers. Thank you very much for your excellent presentation. Thank you.
Thank you.
Thank you, sir.
Thank you.
Now we'll move to the next session, that is on ISCAR Best Paper Presentation Award for Early Research Career.
Dr. Barman,
Yes, sir.
can't hear a word. Can't hear anything.
No, Dr. Barman is announcing for the next session. Dr. Barman, please announce.
Yeah. I am audible?
Yeah,
Yes.
You
Yes,
are.
sir.
This next session is on ISCAR Best Paper Presentation Award for Early Career Researcher. In this session, there are 6 young researchers there. They will present their papers in this session, and from this presentation, we'll select the best presenters, and we'll announce the award during the plenary session of this International Symposium on Coastal Agriculture. And this session will be chaired by Dr. S.K. Sanyal, and co-chairmen are Dr. J.K. Sundarai and J.C. Tarabdar. So before handing over these sessions to chairman, I'd like to introduce the chairman. Chairman is a very well-known person. You know, he is Professor Saroj Kumar Sannal. He is the former Vice Chancellor of the Bidhan Chandra Krishna Vishwavidyalaya. He is a very eminent scientist in the field of soil science. Dr. Professor Sanyal was an adjunct professor in soil science and agriculture chemistry of Indian Agriculture Research Institute and the Bihar Agriculture University. Presently, he is a chairman of many advisory body of the different ICR Research Institute, different state departments, and other organizations. He is a NAS fellow, and he is the fellow of the many prestigious societies, and he has a mentor for many persons, many students from the India and also abroad. And he is the recipient of many prestigious awards. So he will be chairing this session. Along with him, Dr. JC Tarabdar, Jagdish Chandra Charabdar, he is the former UGC Emeritus Professor and ICR Emeritus Scientist and National Fellow and former Principal Scientist of ICR Central Arid Zone Research Institute, Jodhpur. So he will assist our chairman for these sessions, and he's Dr. Tarabdar is also the NAS fellow and the fellow of the different societies and other organizations. He's the first in the world who successfully developed biosynthesized nanonutrients and nano-induced polysaccharides powders for agriculture use. He's a very renowned scientist. I welcome you, sir, in this session. And another co-chairman of this session is Dr. Jitendra Kumar Sundar Rai. He is now presently working as a head division of fish genetics and biotechnology at ICR Central Institute of Freshwater Aquaculture, Bhubaneswar. Presently, he is actively involved in fish genetics and biotechnology research. Now, I invite our chairman and co-chairman to start this session. Thank you very much.
You have to unmute the mic, Dr. Sanal. Dr. Sanal, you have to unmute the mic. Yeah.
Hello, can you hear me?
Yes, yes.
Yes, sir, we
Can you hear me?
Yes, yes, yes.
Hello, Dr. Burman.
Yes.
Everybody is hearing you.
Yes, sir.
I can't hear anything.
So we can hear you, sir.
I can't hear nothing.
Use the earphone.
But we are hearing you.
Please increase your oh.
Kindly adjust your microphone. Adjust your microphone.
It's not there.
Are you able to hear now? Not able to hear?
Connection is lost.
Dr. Sanal, can you adjust your microphone? When everybody is able to hear and we are able to hear you, there is no reason why you should not hear.
Hello. আমার মাইক্রোফোন নেই না, আমার হেডফোন নেই
কি করে
আমি কিছুই শুনতে পাচ্ছি না। কাল পর্যন্ত তো সবই শুনতে পাচ্ছিলাম। হ্যাঁ, আমি সেটিং এ হাইয়েস্ট ভলিউমে রয়েছে। কাল পর্যন্ত তো সবই শুনতে পেরেছি। আজকে আমি কিচ্ছু শুনতে পাচ্ছি না, নাথিং। না না, আমার কাছে নেই, আমার কাছে হেডফোন নেই। আমি দেখছি, একটা চেষ্টা করছি, দেখি পারা যায় কিনা।
So in that case, the co-chairman can start the presentation. In between, our chairman will join.
Yes.
It is so.
Can you hear?
Yes, sir. Yes, sir.
Okay. Then without losing any time, we can start our presentation. But I don't have the list with me. The first presenter, I don't know the name you can announce, and he can start. He or she, I don't know. I don't have the list with me.
No, list has not been passed to you.
Nothing is with
Our first presentation is by the Amruta S. Ajayan. He's from the Department of Soil Science, Agriculture Chemistry, College of Agriculture, University of Agriculture Science, Dharwad, Karnataka. He'll be presenting on the topic green synthesized oxide nanoparticles as a nutrient source for maize grown on calcareous bhatti soil. So we have given the time 10 minutes for presentation and 2 minutes for discussion.
Excuse me, Dr. Barman.
Yes, sir.
Dr. Barman,
Yeah.
it's 12 minutes for presentation and 3 minutes for discussion.
No, Dr. Sanal, actually, we have taken some time in between. So let it be 10 plus 2 or 3 minutes. Like
Yesterday I talked to you over telephone. You said that 15 minutes. That's
No,
what
but-
I'm saying.
Provided things were on time. Now the things were getting late. Next
Okay,
session.
fine.
So let it be 10 minutes plus 2 or 3 minutes.
Dr. Tarafdar, you please
Yes.
announce the name.
Yes.
Dr. Tarafdar, Jagdish,
Yes.
please,
Yeah.
please
Look.
call the participants one by one.
Yes. Please start. Start with, because already it is announced his name. I think he's from Karnataka or something.
Yeah, better we start.
Yes, you can start.
Shall I share the screen? Sir, can you, am I audible, sir?
Yes, you are
Yes,
audible.
yes, you are
Share the screen.
You share your presentation. We enable the presentation mode.
Okay, sir. Start, sir.
Please start. Don't waste time. You'll be taking away your own time.
Respected
Please.
Chairman, Co-Chairman, and all the participants of the webinar, I warmly
Please.
welcome all of you to my presentation on the topic green synthesized zinc oxide nanoparticle as a nutrient source for maize. Okay, we all of us know zinc, it is one of the important essential nutrient that is required for the growth and development of the crop plant. But there is a widespread deficiency of zinc in our Indian soil as well as world over. And in India, zinc has become the fourth important yield limiting nutrients after NPK nutrients. And our nearly 40 to 42% of cultivated land are deficient in zinc. So zinc nutrition is getting so much important under the present scenario. Also in a coastal ecosystem, salinity is a major problem, and the salinity stress will make the plant unable to take nutrients properly. There are reports that zinc nutrition can help the plant in taking up nutrients in a better way and in its assimilation. So we have to give zinc nutrition from the external source to our crop plant to get better yield and as well as to get a better growth in plants. So we have to use an efficient source of zinc. There comes the importance of zinc oxide nanoparticles. We already know that nanoparticles are with unique properties due to their very small size in 10 raised to minus 9 meter. They have very high surface area to volume ratio, and they are also very high reactive. So when we provide the plants with zinc oxide nanoparticle as a nutrient source for zinc, it will be efficiently utilized by the plant because of its smaller size and higher surface area. The bioavailability of this zinc will be more to the plant, As we know that it is an important constituent of many of the enzyme, it will be efficiently utilized by the enzyme, which will reflected in the growth and yield of the crop plant. So we can use this zinc oxide nanoparticle as a fertilizer source for our plant. And here we have tested it in maize plant by using the colloidal solution of zinc oxide nanoparticle as a fertilizer source. So how we can get this zinc oxide nanoparticle? Yeah, it is chemically synthesized and available in the market. But a better alternative, we can go for green synthesis of zinc oxide nanoparticle, and we can use that as a nutrient source. The advantage of this method is that it is very cheap, eco-friendly, and simple method where we use plant extract to synthesize nanoparticle. The plant that are rich in antioxidant principle like polyphenols, alkaloids, antioxidants, we can use that for synthesizing nanoparticle of zinc from their bulk molecules like zinc nitrate or zinc carbonate. Here, the advantage is that the green synthesized particle are more stable than chemically synthesized particle. More than that, during the time of chemical synthesis, so many byproduct released that toxic in nature, and it will cause some environmental issues. So if we go for green synthesis, it will be an alternative solution, as well as we will get stable nanoparticle in an eco-friendly way. So here what methodology followed for the green synthesis is, we have taken 10 ml of calotropis leaf extract prepared at 10% concentration, boiled at 60 degrees Celsius, and added 1 gram of zinc nitrate to the extract, and it is used as the precursor for the green synthesis. We have boiled it until a deep yellow colored paste is obtained, and then air dried in muffled furnace at 400 degrees Celsius for 2 hours. After that, the what nanoparticle we obtained, we characterized it in using UV spectroscopy, particle size analyzer, and scanning electron microscope. So this is the methodology we follow, and we obtained the nanoparticle as white powder. This is the green synthesized nanoparticle, and after that we have characterized it using different technology. For the preliminary confirmation, we have done in UV spectroscopy, where we obtained the absorption peak at 445 nanometer, which confirmed that the size of the particle is in nano size range. After that, we go with particle analyzer, where we find out the size of the nanoparticle as 69.6 nanometer. And after that, the average size of the nanoparticle was determined in SEM, where we found that this nanoparticle is in rod-like shape, and it had a size ranging from 45 to 75 nanometer. And we have checked the EDS analysis of the synthesized nanoparticle and found out that there is 28% purity for the green synthesized nanoparticle. And after that, we have tested the effect of this nanoparticle as a fertilizer source on maize plant, as it is very sensitive for zinc. And before that, we have checked the SEM image of the maize leaf to check that the stomatal aperture size, and found it as it ranging in micrometers range, so that the nanoparticle can be easily taken through this stomatal aperture when we are given as foliar spray. And we have given the treatment. We have given the foliar spray of nano zinc oxide ranging from 50 ppm to 2000 ppm. To comparing, we have given the conventional zinc sulfate spray at 0.5%, and also absolute control with the water spray. Here, we know that the nanoparticle are not water soluble, so we have used ultrasonication to disperse the nanoparticle in the water, and we prepared at different concentration to spraying to the plants. And at 60, when the plant are 30 days old, we sprayed it on the leaves as a nutrient source. So we are observed that at 60 days itself, we have obtained that the growth parameters of the maize plant highest in the treatment 7, which received foliar nano zinc oxide spray at the concentration of 250 ppm, where all the growth parameters such as plant height, leaf area, chlorophyll content, dry matter, everything recorded highest with the foliar spray that is given at 250 ppm, and then higher concentration, that is 500 ppm and 750 ppm, where statistically on par with the treatment 7. And so we can say that 250 ppm itself is enough for the maize plant to get better yield and development. No need to go for beyond 250 ppm. And it is also observed that when we go beyond 1000 ppm, the plant growth shows a reduction as toxicity effect of zinc were observed in this plant. It resulted in decreased growth parameters in maize plant. So this is at 35 days itself, there was means noticeable change in the growth parameters of the maize plant. So we can see that 250 ppm nano zinc sprayed plant, it showed better leaf expansion and internode elongation compared to conventional zinc sulfate spray and control. And at 60 days, we could observe that the plant that received nano zinc oxide spray at 250, 500 and 750 ppm, they were almost similar in their growth characters, and there were no significant difference because it shows that 250 ppm is itself enough for bringing better growth habits in maize plant. And this shows the difference that observed with at 60 days for nano zinc oxide spray 250 ppm, where there was better leaf expansion, internode elongation compared to the conventional zinc sulfate spray given at 0.5% concentration and compared to control. And this is the toxicity symptom that is observed in the plant when we go beyond the nano zinc oxide spray above 1000 ppm. There the toxicity symptom were observed in the plant and the plant growth reduced. So some of the toxicity symptoms that observed in the plant due to higher concentration of zinc and zinc toxicity are necrosis, wrinkling of the leaves, the tip turned into white, then unfurling of the leaves. These are some of the symptoms that we have observed when we go beyond nano zinc oxide spray at 1000 ppm. So here I want to conclude that green synthesis is a cost-effective, simple and eco-friendly method to produce nanoparticle. We can use locally available plants for the effective synthesis of this nanoparticle. After synthesis, we have to characterize for its size, shape, concentration, etc. And after that, we can use it as a nutrient source for the plant, as it is an efficient carrier for the nutrients, and it will help in increase the bioavailability of the nutrient and result in better growth and development of crop plant. And in the pot culture, it is found out that 250 to 750 ppm of the green synthesis nanoparticle is only required for the plants. And if we increase concentration beyond 1000 ppm, there will be severe toxicity in the plant. One thing that we have to take care while using nano formulation is that we have to standardize the concentration for each crop, otherwise it will lead to toxicity based on its bioavailability. So we can hope that this nanoparticle and development can bring so much development in the field of agriculture, as we can reduce the quantum of the chemical fertilizer that we can use for agriculture crop, because its requirement is very less, so it will be efficiently utilized by the plant without any loss, and it can bring some second green revolution in the field of agriculture if it is used in a better way and using the help of more technologies. Thank you, sir.
Open for discussion. Any question? Dr. Tarudar?
Yes. I don't.
Yes, please go on. Dr. Tarudar? Please go on asking.
Yes. Actually, hello? What is the purity of your particle? I mean, concentration.
28%.
What is the purity of your particle?
28%.
Because 28% is pure. Okay. That's why, because normally, if you use more than 100 ppm concentration of zinc oxide, then it is detrimental to the plants. We have seen. That's why
What is the efficiency of zinc fertilization?
Fertilization means
zinc efficiency. What is its efficiency when you use that nanoparticle you have just described?
Sir, means when we use only if you go for conventional, we are saying nearly 0.5%.
No, don't tell me about conventional. I'm asking the particle that you have used. What is the efficiency of? I mean, what percentage?
Sir, only 250 ppm is required for the maize plant.
No, I mean to a plant of a given mass, how much you have to apply so as to get optimum growth of the maize?
Only I have sprayed 30 ml of 50 ppm concentration
and
for the plant.
How much it comes to in terms of amount?
Its amount, sir, it is very, means if nanoparticle means for 250 ppm means only 250 milligram in 1 liter. I have just sprayed only 30 ml of that liter for this plant, for one plant.
Okay.
Professor,
yes.
can I ask a question? This
Sure.
Thanks, Amrita, for the presentation. See, I'm just asking a question related to this zinc oxide nanoparticle toxicity in the microbes in the soil or in the plant itself. Have you done any studies on that?
Actually, zinc oxide have means there are studies shows that if you apply to soil, sometime it will affect the microbial population because it will absorb to the microbial cell and it will cause death of some beneficial microorganism. So we are not going for soil application. It is better to apply in plant itself. Otherwise, we have to make more studies on soil application because in preliminary studies they are saying that there are problem in soil micro with the soil application of this nanoparticle.
It's okay, but you talked about foliar spray. When you do a foliar spray, don't you have the chance of leaching of the spray to the soil or the plant body?
Actually, we are applying very small quantity with so much care we have to apply because if means nanoparticle advantage is that only small quantity only we are spraying, that we should carefully spray it to our plant leaf surface itself. And it means during that time we should take care that the environmental condition that during evening times we have to spray to avoid these loss to the soil. At what time the plant have the peak absorption, that time only we have to spray to the plants.
So if at all your formulation goes for a commercialization, then you need to tell the package of practices how the farmer has to use. Am I right?
Yes, of course. Because if they apply beyond some amount, it is going to cause toxicity for the plant.
Okay.
Okay. Is there any other question? Then thank you very much for your very good presentation. Thank you very much. Dr. Sarobhai, could you please call the next participant?
Just I'll announce the names. The next participant is Dr. Gopal Ramdas Mahajan. He's from ICS Central Coastal Agriculture Research Institute, Goa. Yeah, he'll be talking on the topic hyperspectral remote sensing based prediction of the soil pH and salinity in the soil and soil to water suspension and saturation phase extracted of salt affected soils of the West Coast region.
Thank you very much, sir. Respected chairman, co-chairman, rapporteurs, and all the participants. I'm Dr. Mahajan, presenting at the International Symposium of Coastal Agriculture. If you see, Dr. Daniel Hillel, 2012 World Food Prize laureate, he says that the name of Homo sapiens comes from the word humus, which is important stuff of life in soil. And this explains every existence of human being and importance of soil. But it is undergoing land degradation. If you now see coastal agriculture or coastal ecosystem, two different scenarios, 100 kilometer, 50 to 70% of the population lives within only 100 kilometer, which is only 4% of the earth land surface. 200 kilometer, less than 15% of the earth surface and 3/4 of the population will leave by 2025. In India, we have almost 40% of the largest cities with population 5 lakhs and above. Coastal districts almost have a population of 171 and 14.1% population of the total. So this means that it has a very high demographic pressure and it is undergoing land degradation. There is no doubt it's a self-evident truth which requires no proof, and also said by all the dignitaries in the inaugural function of this symposium. Coastal ecosystem is one which is most fragile and
Yes, carry on.
process. The reason for this is the rise in mean sea level, which is causing the salinity. And eventually in future, 50% of all arable land worldwide will be under salinity. As said by saying 2060, of all the coastal ecosystem, coastal is the one with respect to agriculture and food production being at the very base of poverty elevation. In India, salt affected soil spread over 6.73 million hectare and which caused a food grain loss of 11 million tons approximately, an economic loss of 15 billion every year. In India, it is almost 18.2% of total salt affected soils. And the recent estimate says that in 2018, Mandal et al., 2.5 million hectare is the salt affected soil. But as per Crudiro 2014, these are the best educated guess what we have, because the information, reliable information is less available as salinity is complex, spatiotemporal and dynamic in nature. So it makes it very difficult to measure, monitor and manage it. Although the conventional method are the most accurate, but they are time consuming, very expensive. And we need some real-time quantitative assessment for better understanding of these soils. In this context, we can see hyperspectral remote sensing as a modern valid alternative. Though in this context, it is not said, but Peter Drucker said, if you can't measure, you cannot manage it. And to the best of our knowledge, very less is known in salt-affected soils of West Coast region of India about the relationship between pH and AC and their prediction using the remote sensing. And this makes it to undertake the investigation hyperspectral remote sensing based prediction of soil pH and salinity in water suspension ratio saturated paste extract of salt-affected soils of West Coast region of India, with the objectives to study the relationship estimated pH in AC in different extraction method and to predict it using the remote sensing method. For this, we took a sampling campaigns on the West Coast region with 216 locations with a sampling depth of 0.15. This is the schematics of the methodology, and it covers 3 steps. The first is step 1, measuring soil pH and EC in 1:1, 1:2.5, and 1:5 saturated paste extract. And hence, after it is referred as pH 1:1 and so on, and pH E. Similar is for the electrical conductivity. Second part of the data collection is the spectral measurement. The soil samples were employed for spectral measurement using contact probe of the spectroradiometer, and we collected the data in 300 to 2500 nanometer range. The similar samples were employed for laboratory measurements, and the relation between this was evaluated using multivariate analysis, and nutrient sensitive wavelengths and algorithms were identified. This made 216 samples with 10 parameters each, and this data was divided into 2 splits. One is calibration data set.
Dr. Saruvda, could you hear?
No, I think, sir, his network is unstable.
Yes, network. I can't hear now. Certainly, it got snapped.
Yes, sir.
And how can you judge the participants if you don't hear them?
Yes, I am hearing you.
I'm not hearing anything. I am hearing you, but not the participant. Jagdish, can
Not
you
the participants. Okay.
I'm not hearing.
Yeah, I am hearing.
I'm also hearing, no problem.
Okay, I am taking care. I am taking care. No problem.
Please take care.
He is having the network problem. That's why he's
Can't hear now. It was going on all right, but now it is snapped.
I have sent everything to everybody. There is a common link sent to everybody. And why don't you access that? There is a common link, and there are Plenum lectures 6, 7, 8, 9 all together have been clubbed in.
Sir, sorry for the interruption. Yeah.
Could you please resume?
Yes, sir. And different multivariate analysis techniques were used: partial least square regression and principal component regression. Predictive ability was assessed using different multivariate prediction models, and statistical softwares like SAS, R-Core Team, and Microsoft Excel was utilized. Coming to the results and discussion of the objective one, you can see here from the descriptive statistics, the pH E of the study was from 3.06 to 7.39 with an average 5.33. ECE was 19.96 decisimon per meter. We can see here that the variability of electrical conductivity was more compared to the pH, and the non-significant result of test of means, variance, and distribution and coefficient of variation explain that the calibration and validation data set represents the variability in the full data set. If you analyze the correlation between different parameters, we can see here that pH analyzed in different extraction method correlates with each other with correlation coefficient 0.85 to 0.90. In case of EC, it is 0.91 to 97. But pH and EC in these soils are weakly correlated, 0.03 to 0.29. The regression between electrical conductivity in saturated paste extract with the 1:1 and different ratios, here you can find that it regressed with a regression coefficient of 0.84 to 85, which is strong and significant. At the same time, 0.72 to 73 in case of PHE, which is correlated with 1:1, 1:2, 1:2.5, and 1:5. On the right hand side, you can see the results presented graphically. The regression equation, such kind of regression equation could be utilized in case of West Coast region, where typically salinity is associated with acidity. EC is broadly 3 times that of EC 1:2.5 and EC 2.5 times of 1:2.5. Datta in 2017 has found out this relation, and ECE is related 2.2 of EC 1:2. The second objective results are like this. You can see that the variability with respect to spectral reflectance in the samples exhibited. The spectral reflectance decreased with increase in salinity levels. Thus, very strongly saline soils have the least reflectance. However, the non-saline has the highest reflectance. It is contradictory observation to earlier studies. The prediction accuracy of the best performing models have been given here. pH 1:2.5 partial least square regression. You can see R is 0.82 between predicted and actual values, and for validation it is 0.79. The best parameter which was predicted was electrical conductivity in saturated paste extract using the PLSR with R 0.89 and 0.87. So 1:1 close agreement between actual and predicted values can be seen with calibration accuracy 0.78 and 0.72. To conclude my presentation, the regression equations between ECE and others which have been developed can be utilized for the salt affected soils of West Coast region where salinity and acidity are related. pH and EC in the soil is weakly correlated. PLSR is the best method for predicting the pH and EC, and the parameter ECE was best predicted, and we can see that soil saturation paste extract of the soil can be monitored using the near infrared, visible near infrared remote sensing. But it is not good to talk about everything good about this technology. The coastal areas proposes some challenges: cloud cover, undulated topography, small and marginal land holding, and multiple stresses are present at one time. So these are the limitations. However, it also paves a way for future research that we use this pre-processing technique, also explore the aerial and satellite-based data characterizing salinity at ionic composition, and in this way, the government's initiative on guidelines for acquiring and producing geospatial data services, including maps, could be one of the boom for undertaking such kind of studies. Finally, acknowledging the funding agency for the project extramural research grants, ICAR Niyazam Baramati for instrumentation facility, Director ICAR CCRI, farmers who extended assistance in sampling, team at ICR, ISCAR Kennington for giving me the opportunity, chairman, member, and rapporteurs of the session. Thank you very much.
Thank you, Dr. Mahajan. The paper is now open for discussion. Any question, please? Any question? Dr. Mahajan?
Yes, sir.
I have just two small queries.
Yeah.
You had very good correlation between ECE and EC at all dilutions, as well as the PHE and pH at all dilutions, right?
Yes.
Now, I believe that you are aware of what is known as suspension effect in pH measurement in soil. Now, the extent of suspension effect will be different in 1:1 extract from 1:2, 1:2.5. But surprisingly, all of them were very well correlated with the corresponding pH in the saturation extract. And so in the ECE, between the correlation between ECE and EC at all dilutions. What could be the reason? This is number one question. And number two, you said that the reflectance from the salt affected soils having white patches was the lowest, whereas from the non-saline soil, it was the highest. It is contrary to what we know, right? The white surface reflecting more or absorbing more. They should reflect more, is it not?
Yeah.
So could you please answer these two queries?
Yeah, sir, regarding first questions, I will not be able to explain that. However, the second question, we have also found it concordant with some of the studies. As you rightly said, the salt white crust should be there. So it should be the more salinity should have more absorbance. But the presence of hygroscopic salts of magnesium and sodium of chlorides has been one of the reasons to which this has been attributed. So this result we have also clarified from one of the research papers from November 2017, who also have found the same results, and also by Srivastava et al. From NBS SLU. So though it is contradictory, but hygroscopic source.
Is it R.C. Srivastav?
Yes, sir.
R.C. Srivastav from NBSS and LUP?
Yes, sir.
The magnesium sulfate in the heptahydrate form, does it interfere with the reflectance?
It absorbs
the magnesium
moisture.
Sulfate heptahydrate.
Yeah, the hygroscopic nature absorbs.
It's a desiccant.
Mm-hmm.
Okay. Any other question, please? Comments, remark? Well, if there is none, then thank you very much, Dr. Mahajan, for presenting a very good paper.
So
thank you very
for
much.
opportunity and interruption. Thank you.
So I invite the next speaker, Peter T. Bithi. He is from University of Development Studies, Ghana, Africa. He'll be talking on the subject, Development of Selection Index for Agroforestry System. Dr. Peter, please.
Good afternoon, Mr. Chairman and everybody present. I'm trying to share my PPT right now. Can you enable me to be able to share, please? Can you hear me?
We can hear you, but we can't see your presentation.
You first open your presentation, then you go to the share screen, that's option, then you click that one.
Yeah,
then
now we can see you.
Yeah, it is okay.
A very good afternoon, Mr. Chairman, and all panelists present, co-presenters. I'm Peter T. Bithi from Ghana, but I have been in India, New Delhi, where this work took place. This afternoon, I'm presenting on the topic, Development of Selection Index for Agroforestry Systems. And this is going to be the order of presentation. We go through introduction, motivation, through to conclusion and reference. Now, agroforestry refers to an intentional combination of trees with crops and sometimes livestock, which involve intensive management of the interactions between the components as an integrated ecosystem. In agroforestry, the different plant components compete for resources in the neighboring environment. And for this purpose, the plant components have to be chosen carefully and well managed to ensure a sustainable agroforestry systems. Now, the interactions among trees and crops, though may not be seen physically, reflect in the overall productivity of the system, such as crop yield, fodder, and wood volumes. For this reason, it is important that food biomass systems are quantified in a way in order to demonstrate their relative effectiveness and to ensure their utility. Now, this slide shows some demonstrations of agroforestry systems in different cases. We have the first case, both crop and trees. The second case, animal, pasture, and trees in that different format. Now, the motivation for this work is based on the following, that various indices, including competition index, relative crowding coefficient, relative yield totals, and land equivalent ratios have been developed and used in assessing intercropping systems. And for this, Jaggi and et al. Obtained the land equivalent ratio for assessing advantages of systems in agroforestry experiments. However, land equivalent ratios is simply an index based on combined crop yields and is mostly suitable for comparing crop yields when mixed cropping is involved. Meanwhile, in agroforestry systems, multiple products are produced. And for this reason, the problem comes. The question is, how do we assess these multiple products to say that a particular system is very productive? To tackle this, it is necessary that we consider a way of combining the various components of an agroforestry system and see whether we can synthesize it together to produce an index. So, considering this, one major issue is that the various indices that have already been mentioned are not actually designed for agroforestry system, especially because of the nature of trees. Trees grow for long in the field, and they take long and they produce different products. And it is in line of this that we deem it necessary to explore the possibility of developing a suitable index for an agroforestry system. So based on this, the objective of this research was to develop an appropriate index for evaluating the performance of different agroforestry systems. The methodology involved trying first to come up with a selection index, which here in called agroforestry system productivity index. The index is simply defined as a sum of the relative proportions of the equivalently scaled yields of trees and crop components of a system. Now, let's consider an agroforestry system where there are about T tree species and C crop species, which are being run for over several years, say X. We developed the system by defining some parameters that will be of interest to the farmer and maybe to the researcher. So we consider those parameters and try to define them as well as assign scales to them. First of all, in an agroforestry system, there are going to be trees and crops, where in that case, one has to consider what is the importance of the trees relative to the crop. For this reason, a weightage parameter is assigned as to whether the tree is more important to the farmer or the crop is more important to the farmer. The next thing is, if you consider where there are different tree species, the farmer has a choice of choosing among these tree species. For example, in this slide, we have mango, cashew, we have jackfruit, and then we have cereals. Among these trees, a farmer may have preference for mango. For instance, in India, a mango tree is not only useful for its fruit, but it also is a tree used in festivities during some of the Hindu festival celebrations. And so for this reason, a farmer may prefer that particular tree, while a jackfruit in hilly areas may be preferred because besides wood, it also produces fruits that are very beneficial to the farmer. The crop component also is concerned about choice of crop. We know that farmers usually have staple crops that they use, and that is the main crop. So when you introduce a new crop to them, no matter how useful that crop is, they will first of all desire to produce their staple crop, which they will have their main food from. Then any other crop they may add. And in this case, farmers may have preferences of one crop over the other. This slide just shows a few of the cases. We have maize, cowpea, green gram, and wheat. And farmers may have preferences. And in that case, they have to assign weightage parameters to these different crop species. So based on the various factors raised, the following parameters are defined. The first one is omega, which refers to the weightage parameter for relative importance between trees and crops. And then the second one is, in the first case, if the farmer considers the tree to be 60% more important, then the remaining 40% will be the importance of the crop species used. The second case is eta, and this refers to a weighted parameter representing the preferences of trees. If the farmer prefers one tree over the next tree, it is expected that the farmer will give a higher scoring for that tree relative to the other tree species that are of less importance to the farmer. And this should be based on, this ranking should be based on maybe an expert knowledge. Farmers are known to be experts in the choice of what they use in their field. The next is row, which is a weightage parameter representing rank of crops is similar to the trees also. The farmer chooses which crop is more important and so should give a higher weightage to that particular crop relative to the other crop that may not be very important. Now, when the various crop yields, tree yields like wood, timber, forage, or grain yield from crops are harvested, the steps of producing the index involve converting these values into monetary terms. For instance, maybe in Indian rupee, we have to find out how much is the cost of a quintal or a kilogram of a particular crop yield. When this is done, we have the following terms: the sum of monetary values of all tree species, then monetary values of the total yield of crop species, and then the sum of these monetary values. Now, the selection index can be developed in 4 different scenarios. So we are going to consider those 4 scenarios. The first scenario is that there may be a situation that the trees, all tree species under consideration are considered to be equally important. No one tree species is more important than the other. In that case, we don't need to rank the tree species. And then crop species are also considered to be equally important. Therefore, no need for ranking. In that scenario, the selection index is developed. That's the first equation given here. for a particular year, in any given year, the selection index is what is produced here. The first component is the tree yield component, and the second component is the ratio coming from the crop yield component. So these two ratios summed together will give us the score for that particular system, agroforestry system. Now, that is for a particular year. What about if the agroforestry system has run for several years, 5 years, 7 years, 10 years? What happens? We can find the average performance of that particular agroforestry system over the several years. And that is what gives us the second equation. We take those components for all the years and find the simple average of it. The second scenario is that the trees are not ranked. All trees are considered important. But among the crop species, the farmer has preference of one crop over another crop species. And in that regard, the row parameter, which is ranking of crop species, is incorporated in the crop component. When that is done, we have the selection parameter, the selection index produced for a given year, as well as for several years. If we have several years, you have to find the average of it, which is given in the second scenario. The third scenario is that the farmer considers that the tree species are ranked. Some tree species are more important than other tree species, while the crop species are all equally important. And in that case, we introduce the parameter eta, which is a ranking parameter for different tree species captured in that component. And so we have for one particular year, again, in the year I, we have the selection index. And then for several years, we find a simple average. If we have X years, we get the simple average of it. Now, the fourth and the last scenario is that the tree species are considered to be ranked. Some tree species are more important than others. At the same time, crops are also ranked. Some crop species are more important than other crop species. Then we have to rank the tree species and rank the crop species as well. And that is captured in this fourth scenario, in the particular selection score, as well as the second situation when we are considering several years. Now, what has been the development of this selection index can be summarized in this particular chart over here. First, you obtain the various yields from crops and trees and convert them into an equivalently suitable scale, preferably monetary terms, because it is easy to compare everything in monetary terms. In that case, we have the crop tree component and then the crop component. And we pull these values together as given in the various equations presented earlier to compute the ASPI, that is the Agroforestry System Productivity Index. Now, if you have different agroforestry systems, you compute a value for each, a score for each one of them. Having produced different scores for all the different systems, you compare these values, and the one with the highest score is the better performing system. So that is why we talk about ranking of the agroforestry selection index scores. The application of this index, some work was done in Jansi several years ago, and based on the data that was produced in the agroforestry there, this selection index that has been developed was applied to the data, a similar fashion of that data to see how it works. The scenario considered here is that the trees are not ranked. That's the first scenario. We are not ranking the trees. We are not ranking the crops. We consider all trees to be equally important and all crops to be equally important. About 5 tree species are considered, and then 5 crop species are also considered. So the tree species are named 1, 2, 3, 4, 5, and the crops are A, B, C, D, E. The first values are the crop yields, and then the second values in terms of money, Indian rupee, and then the second values are the tree yield, fodder in particular. So we compute these values and go further to summarize the scores. The values given are the scores, and then the ranking. The up values are the scores. The lower values are the ranking. We see from the ranking order that the best performing system is the one combining tree species 5 and then crop species D. So these various agroforestry systems are ranked over here. We can see 5D is greatest, is the best performing, followed by 5A, 5C in that manner. And the least performing system is 3E. While we have done this, the question is whether what we've done, there is any statistical significance in it or not. This we are not able to tell right from the scores because the distributional properties of these scores are still being understudied. But to be able to perform, to assess this one, we consider a non-parametric approach, and that is Kruskal-Wallis test, which could test whether these scores are significantly different or not. And when the Kruskal-Wallis test is applied, we see that the test is significant as indicated by the p-value here, 0.004. So it is significant at 5% level of significance. And then again, the Kruskal-Wallis approach is able to rank, considering the 5 tree species and then the 5 crop species, is able to rank these different agroforestry combinations. From this ranking, we see that the best performing one is 5D, as indicated here. Those that are in deep color, the color is also different here. These were the best performing systems, which agree with the normal ranking that was done by the system. Now, having done all these things, we realize that it is then important to consider, particularly for agroforestry systems, which is very complex, but most appropriately used by our farmers almost all over the world, that systems, an index is produced for them, so they can use it to assess and determine that this particular system is better, this 3 crop combination is better than the other. So in conclusion, the agroforestry system productivity index is reliable as confirmed by the Kruskal-Wallis test. And so it is recommended for use in comparing different agroforestry systems. This work that I have just presented, when doing this work, I had received help and assistance from senior scientists at ISCAR in India, and they include Dr. Sini Vagis and then Dr. Sima Jagi. These are the references that were considered in preparing this particular material for this presentation. Thank you very much for your audience.
Thank you, Dr. Peter. The presentation is now open for discussion. Any question or any comment, please?
Sir, a question from my side, sir.
Yes, please.
Yeah, Mr. Peter, it's wonderful to listen to you. Because you come from Ghana, and this, yes, how applicable is the selection index as far as your agroforestry is concerned?
In Ghana, agroforestry is one of the common practices that is found among a lot of our farmers, because most times when they clear their farms to plant crops, usually they do not clear trees. They leave the trees in it. So the only challenge here is that the systems that are currently available are not planned experimental fields, but every farming system, you will find that farmers leave trees in their field. And so most of these trees are also fruit trees that they have on the farm. So this particular selection index will be applicable in the sense that what needs to be done now is to go to the farmer's field, get a way of measuring the volume of product output from the tree, particularly the tree fruit, as well as the forage from the trees. Then the crop yield is also measured, as well as the residue, which can be used to feed animals. If we can produce this, measure these yields, then it is easy to convert them into the suitable scale, and then the index is computed. Based on this, we will be able to compare different systems and can tell which system is doing well or not. Actually, I'm currently back in Ghana, and it is part of my plan to apply this work in the field right now, because I have resumed work. I work in the university, I've resumed work, and part of my research is now to take this selection index to the farmer to begin to assess the various systems that are available. Thank you, sir.
Thank you, thank you.
Thank you, Dr. Peter, for your very good presentation. Dr. Tarudha, could you please call the next participant? Jagdish. Next participant, please.
Next is Remeya. She is from ICR Central Institute of Fisheries Technology, Kochi, Kerala. On behalf of the organization, I request all of you, please maintain your time allotted for your presentation. Thank you.
10 minutes for presentation, 2 minutes for discussion.
Yeah. Remeya, please share your screen.
Can I start, sir?
Yes, please. Go ahead.
Respected chair, co-chairs, participants, ladies and gentlemen, a very good afternoon to all of you. Myself, Dr. S. Ramya, I am working as a scientist in ICAR CIFT Cochin. Today, my topic of presentation is development of chitosan-based novel antioxidant film for fish packaging application. So currently, the whole packaging world is focused mainly their research on active packaging technologies. Let me tell you that the global active and intelligent packaging is valued at $17.5 billion in 2020, and it is expected to reach a value of $25 billion in 2026. Now let's see what is active packaging and how it is different from the traditional packages. The traditional packages or the commonly used plastic packages are generally they are passive. It means they act just like an inert barrier to the external conditions. They are not supposed to interact with the food. Unlike those conventional packages, an active packaging system is designed to interact with the contents or the surrounding environment. So basically, it's a kind of interactive packaging. So there are many examples of active packaging systems. It can be an oxygen scavenger or a moisture absorber, or it can be an antimicrobial releasing film or an antioxidant releasing film. Among these active packaging systems, nowadays, antioxidant films are getting more attention because, as we all know, oxidation is a major problem affecting the quality of any food. So coming to antioxidant packaging, it's a kind of active packaging. It is one of the most promising versions of active packaging. Here, an antioxidant substance is incorporated into the packaging material for releasing onto the food surface. So our first objective was developing an antioxidant releasing packaging film and its characterization. Here the thing to note is that the packaging material used can be synthetic or a natural one. We have selected a natural packaging material, that is chitosan. As some of you know, chitosan is extracted from the crustacean shell waste mainly. It is a wonder molecule with n number of properties like biodegradability, biocompatibility, environment friendliness, and whatnot. And more importantly, it has got antimicrobial efficiency and inherent antioxidant property. Moreover, it has got very good film forming ability also. So we have chosen chitosan thinking of all these properties, but currently the packaging materials, food packaging material especially, are mostly petroleum-based plastic packaging materials. They are virtually all non-biodegradable and some are difficult to recycle or even reuse. So it creates significant source of environment pollution. By using a biodegradable packaging material like chitosan, we can avoid this problem to a great extent. So that was another reason for choosing chitosan as the packaging material. So we have selected the basic packaging material. Now we have to select the active substance. Again, we have selected a natural substance, that is essential oil. They are well-known antioxidant agents. They are aromatic volatile oils extracted from plant parts, and they are rich in phenolic compounds. So the antioxidant efficiency of the chitosan films can be enhanced by the addition of essential oil to the film. Moreover, when we do so, we can safely replace the synthetic preservatives or antioxidants which are otherwise added to the food. So first experiment was extraction of essential oil and evaluation of its chemical composition. The material which we used was a rhizome of ginger, Zingiber officinae, and the essential oil was extracted by hydrodistillation method using a Clevenger apparatus. The yield of ginger essential oil was 0.5%. Then the chemical composition of the ginger essential oil was analyzed using gas chromatography mass spectrometry, and we could see that zingiberine, geraniol, and beta-cis-philanthrin were the major compounds present in ginger essential oil. Then the total phenolic content and total flavonoid content of the extracted ginger essential oil was analyzed. Because the antioxidant potential of a plant part or a plant extract or an essential oil is greatly correlated with its total phenolic and total flavonoid content. The total phenolic content of the ginger essential oil was 1041 microgram gallic acid equivalent per gram, and the total flavonoid content was 250 microgram rutin equivalent per gram. In the second experiment, we have prepared the chitosan-based active film and characterized it. The film was prepared by solvent casting method by incorporating ginger essential oil at different concentrations from 0.1 to 1% to 1% chitosan solution. 280 was used as an emulsifier and glycerol was added as a plasticizer. On the left side, what you see is a pure chitosan film, and on the right side, it is chitosan-based antioxidant film containing ginger essential oil. Then the films were characterized for different properties. Initially, we have checked the antioxidant effect of the chitosan film added with ginger essential oil. The assays performed were DPPH and ABTS radical scavenging assay, ferric reducing antioxidant power assay, and total antioxidant capacity. And we could see that when we added ginger essential oil, there was a remarkable increase in the antioxidant potential of the pure chitosan film. For example, for the pure chitosan film, the DPPH radical scavenging potential was just 9.5%, which significantly increased to 36.1% when we added 1% ginger essential oil to the chitosan film. Same was the case for all other assays. In addition to antioxidant efficiency, we have also checked the antimicrobial property of the developed film by diffusion assay using Muller-Hinton agar plates against a group of food spoilers and pathogenic bacteria. The synthetic EVOH plastic film was used as a control, which did not show any activity towards any of the tested organisms. The pure chitosan film showed activity against some of the tested organisms. And when we added ginger essential oil to the chitosan film, it showed activity against almost all the tested organisms. And we could see that Staphylococcus aureus, the gram-positive bacteria, was the most sensitive organism, and Salmonella was the most resistant one. The second objective was to determine the efficacy of the developed packaging film for managing spoilage on an entire model food. The fish we have selected was Barracuda Spirina jello, which was purchased from Veravel Fish Landing Center in Gujarat. The fish, after cleaning and dressing, were cut into steaks of 2.5 centimeter length, weighing around 50 grams. Then the fish steaks were divided into two groups. The first batch was packed in EVOH pouch without any wrapping, that was controlled, and the second batch was packed in the antioxidant film, and both the groups of fish steaks were stored at 2 degrees Celsius. And during storage, the different quality parameters of the fish steaks were analyzed using standard methods. The proximate composition of the Barracuda fish steak revealed that the fish is a medium fatty fish. The fat content of the fish was 6.1%. Coming to biochemical quality changes, total volatile basic nitrogen, which is usually considered as an index of fish spoilage, and the upper acceptable limit of TBBM in chill stored fish is 30 to 35 mg%, which was crossed by the control sample on 12th day of chilled storage, but it was exceeded only on 20th day by the developed antioxidant film wrapped sample. Coming to lipid quality, the very important fact is that oxygen is a major concern in food packaging in relation to its shelf life, and the lipid oxidation affects the quality of the fish very badly. So we have checked the lipid oxidation using free fatty acid value, peroxide value, and thiobarbituric acid value. And we could see that compared to control, the fish steaks wrapped in the developed antioxidant film had lower values of free fatty acid, peroxide value, and thiobarbituric acid value, clearly indicating the antioxidant potential of the phenolic compounds in ginger essential oil and also the superior oxygen barrier property of the developed antioxidant film. Coming to microbiological quality, initially the counts of the cyclotrophic bacteria were more compared to mesophilic bacteria in both the groups of fish steaks, but during storage, cyclotrophs multiplied rapidly and dominated the spoilage flora. And we could see that there was a lag phase for the total mesophilic count when the fish steaks were packed in the developed film, which shows its antibacterial efficiency. Also, the upper acceptable limit of 7 log CFU per gram for the total mesophilic count was exceeded by the control sample, which was not wrapped with the developed film, was exceeded on 12th day. And it was only on 28th day, the value was exceeded by the fish steaks wrapped with the antioxidant film. Changes in the sensory quality, the results of the biochemical and microbiological quality coincided with the results of the sensory analysis. And based on the sensory quality, the shelf life of the control sample was estimated as 12 days. And for the fish steak sample wrapped with the antioxidant film had a shelf life of 20 days. So there was a clear increase in the shelf life of the fish steak sample when it was packed in the developed antioxidant film.
Please wrap up.
Coming to the conclusion, So to conclude, we can say that the biodegradable antioxidant film based on chitosan added with ginger essential oil, it has got very good potential to be used for food packaging application because it extends the shelf life of the food it carries without risking the consumer's health. Moreover, with the increased use and manufacturing of bioplastics of marine origin, we can expect a greener and a more sustainable future for our planet. Thank you. Thank you all.
Thank you. The presentation is open for discussion. Yes.
Yes, sir.
Please go on.
Yeah. Dr. M.A., actually, this particular product, what you have developed, is it this Barracuda specific or the same formula?
No, sir. We have used for different fishes.
Okay.
Yeah, this is effective in case of any food material. Not only actually this chitosan packaging films and edible coating we can use for other vegetables, fruits, etc. also.
So how ready you are now if somebody asks to take this technology for its application, how ready you are?
Sir, actually, recently one entrepreneur from Andhra Pradesh have approached us for taking this technology. So the packaging film, the development of the film is ready. The only consideration may be cost. Like in the case of any like organic products or any natural thing, the cost is compared to the synthetic plastic film, the cost is a bit higher. But nowadays in market, many such natural polymers, all of them are costlier than the synthetic plastic films. But people are ready to take it.
See, you talked about other species also can be used to this technology, but question is looking into the shelf life of the fish. You know, whether it's a freshwater or brackish water, marine fish, they have their respective characteristics. So
yes, sir. Yes.
Particular, like in a product use, so how do you looking into the characteristic of the fish and the shelf life when you use this type of packaging actually?
Yes, sir. Actually, we have tried this for fatty fishes, lean fishes. Means lean fishes means fishes with less content of fat. Actually, it is it can help in increasing the shelf life of all kinds of fishes.
No, increase in the
But
shelf
in case
life, can you quantify it?
Sir, it varies. Shelf life. Suppose a fatty fish like a sardine or mackerel, in general, if it is even for a control sample, the shelf life may be only 7 days. But if you take a fish like cobia, without any preservation, if you only use ice or if you keep in refrigerator also, it may keep well for 12 or 16 days. So from the control, from that point, how far you can increase the shelf life. So you can for some fishes, you can double the shelf life, for some maybe 1 week, 7 days. It varies, but definitely it can help in increase the shelf life. And also this is a biodegradable packaging material. So
Okay. No, the last question is whether this dressed or undressed fish have any impact on this type of packaging?
Sorry, sir, I didn't get.
Dressed or undressed? You suppose you need a fish as a whole, or you need to be de-skinned or de-peeled?
Sir, whole fish also we can use for dressed fishes, for anything. Like if it is a whole fish, like if for control also, if it is a whole fish and dressed fish, there is a difference in the shelf life because once you remove the gut and all, the gutted fish and the whole fish, the shelf life may be a little more for the gutted fish compared to the whole fish.
Thank you. Thank you, Dr. Amaya, for a very good presentation. May you have the next participant?
Thank you, sir.
Thank you. You're welcome. Next participant, please.
So the next participant is Dr. S. Malik from ICR Central Soil Science Research Institute, Cannington. Dr. Malik, please.
Yes, sir. Am I audible, sir?
Yeah, you are audible. Can you share your screen, please?
Sir, I have already shared it, sir. Is it visible, sir?
Yeah. Yes.
Okay. So, good afternoon, sir, and my fellow participants. My name is Saurabh Malik, and I am a PhD scholar from Department of Agriculture, Chemistry, and Soil Science, University of Calcutta. And my today's presentation is on changing salinity dynamics in different language systems of climatically vulnerable Indian Sundarbans. As we all know that soil salinity is a major and widespread challenge throughout the world, where 952 million hectares of lands are affected. Like other countries, India is also not spared by the outraging effects of salt, where out of 10.78 million hectares of coastland area, 3.1 million hectares is salt affected. Thus, due to the presence of excess amount of salts in the soil, the crop cultivation are hampered in these regions. Moreover, these regions face other constraints such as drainage, congestion, climatic hazards like Ayla, Amphan recently, as well as lack of irrigation water. So, keeping these problems in mind, the above study was conducted in the Bashanti block of Sundarban region with the following objectives. The first objective was to understand the spatio-temporal change of the chemical characteristics of soil for the dominant land use systems. The second was to study the salinity dynamics for the prevailing land use system. And lastly, to evaluate the possibilities and options of the land management practices to manage soil salinity. For these things, the methodology which were followed: number one, collection of weather data, collection of soil samples and piezometer water samples from the different land use systems, assessment of those soil and water samples, and formation of a predictive equation which can be helpful. For this, in the figure, we can see that there are 114 sampling points which are shown aside in the figure. So moving to the next slide, the analysis of temperature or the weather data which were collected from the meteorological department from CSSRI Canning Town, and with this data reference evapotranspiration was calculated. It was seen that the temperature varied from around 18 to 31 degrees centigrade, and the rainfall was mainly concentrated in the 3 months, that is June, July and August. Moreover, the evapotranspiration was inversely related with the rainfall. Thus, due to these climatic fluctuations, the cropping pattern in this region is that in the wet season, mostly all the areas are under paddy cultivation, approximately 94%, which gets reduced to 18% in the dry seasons. So next slide shows me the different amount of chemical parameters for the different land use systems. For the different land use systems, where it is clearly visible that the study parameters had a hike in summer than in that of the winter season. But one striking feature is that in the land shaping model, the rise of EC was less compared to the other systems. As all these huge amount of data are a bit tricky to handle as well as to compare, so I took the help of ArcGIS software so that I can have a pictorial view of it, so that the whole Bashanti block is easy, so that the data are easy to correlate if we have a picture in front of us. So this slide shows us the spatial view of the soil EC in winter as well as in summer, that the regions which show the less EC value in winter had a higher EC value in summer. So this is a better way to correlate in seeing a picture rather than correlating different types of tables or data. So similar observation was also noticed for total soluble anions, that is chlorine, etc., as well as cations also. So coming to the next slide, which shows that after seeing those previous maps, moving forward to the land-specific changes in soil EC. So it is seen that the rice fallow system showed the highest temporal change, and the least was for the RR system, that is rice system. And the lower graph shows the EC value of the piezometer water collected from the different arable land use systems, where almost a steady trend was followed throughout the year. Now moving to the next slide, which shows the change in soil EC with depth, where in monsoon almost all the systems had a constant value with the depth except for rice fallow, whereas the variations of EC with depth were seen during the summer seasons. Now, after gathering all the observations and all the data, these data were fed into SPSS software for generation of an equation which can be helpful for predicting soil salinity. It was seen that the model was successful in predicting soil salinity with an 80%, approximately 80% accuracy. Here the predictors which were used were average rainfall per day, evapotranspiration per day, and piezometric water EC. and the dependent variable was soil ECE. Moreover, I tried to formulate few land use specific equations where the equations for rice pulse system had the best accuracy of approximately 82%, followed by others. Whereas we can see that the rice system, the equation was not that much effective, maybe due to stagnation of water, which needs more study. Now moving to the next slide, which shows that the relationship between the ECE with other cationic and anionic properties of soil. Thus, if we are able to predict soil EC with a handsome accuracy, we can also predict the different cations and anions with the equations in the graph, shown in the graph. So it can spare us from analysis as well as save time. Now coming to the management part. In this scenario, which land management practice should be made or used to curb soil salinity as well as to maintain soil health? In doing so, I have analyzed soil carbon stock was estimated for different land use systems, and it was seen that with rising salinity, soil organic carbon decreases, except for in mangroves. As in those systems, there is a continuous charge of carbon from the leaves, root, etc. without any drainage due to any cultivations. Therefore, coming to the next slide, we can just correlate the ECE with the soil organic carbon stock, where we can see that the rich furrow system showed the best practice that can be possible modifications in this suitable region. So, to conclude my presentation, that the soil salinity showed a wide variability with time and depth. The predicted equation can come in handy in predicting soil salinity as well as the chemical parameters of soil. And lastly, the rich furrow system is the most climatic resilient modifications that can be adopted in this present scenario. Thank you, sir.
Thank you, Mr. Malik. Now the presentation is open for discussion. Question and comments, please. Mr. Malik?
Yes, sir.
I found that the change of EC, for instance, in rice fallow system,
yes, sir.
During monsoon, there was more EC in greater depth compared to other systems, rice, vegetable, etc. What could be the probable reason? Does the presence of root of any crop following the rice have a role to play in affecting the ECE of the lower depths?
According to me, or as per the findings, it may be due to in the monsoon regions due to heavy downpour. The soil may get soluble and it just reaches down to the lower levels. So
why does it stay in the lower level? Why doesn't it go down farther to the groundwater table? This being a sandy soil, naturally would be very permeable, and the permeability rate, percolation rate will be very high.
So here the soils are mainly the clay soil, sir. So,
soil. From
yes,
which
sir.
place?
So from Bashanti. Yes, sir, Bashanti block, sir.
Bashanti, I see.
Yes, sir. So from Sundarban regions. And mostly the groundwater table is very near the surface also, sir. So it does not percolate much
down to the groundwater.
Yes,
one more question. You have the different cropping systems. You have certain equations.
Yes, sir.
With the coefficient of variation R square, right? Regression.
Yes, sir. Yes, sir.
There you have rainfall and evapotranspiration. You have taken as separate factors.
Yes, sir.
Don't you think that they are dependent on each other?
Yes, sir.
If you have more rainfall, you have less evapotranspiration.
Exactly, sir.
Can you take them? Can you treat them as separate independent factors?
Yes, sir. I will look into it. So I have taken one more factor, that is piezometer water EC also.
I know that you have gone perhaps principal component analysis or some other analysis to identify the parameters. But my question is that the evapotranspiration and rainfall are related to each other inversely, as a matter of fact.
Exactly.
But can you treat them as independent parameters in a regression model?
So I have to see it, sir. It can be done, sir.
Any other query or comments, questions? If not, thank you very much, Mr. Malik, for a very good presentation.
Thank you, sir. Thank you.
Our last participant, please.
Yeah. So I'll request Satyabhama N from Pandit Jawaharlal Nehru College Agriculture Research in Karaikal. Madam, please.
Yes, sir. Yes, sir. I'm here.
Yeah, you are audible.
Please share your
Okay,
slide.
sir. Okay, sir. Okay, sir. Okay, sir. Oh, okay.
Please go ahead.
Okay, sir. Okay, sir. Sir, my slides are visible to everyone?
Yes, yes.
Okay, sir.
Please go ahead.
Good afternoon to everyone. I'm started my presentation with this words of Abdul Kalam. My research topic is nitrogen dynamics in organically cultivated paddy soils of coastal Cauvery Deltaic region.
Could you please go to presentation mode?
Okay, sir.
Expand the slides.
Okay, sir. Okay, sir.
Yeah, this is lengthwise expanded. The breadthwise?
Sir?
Wide. It should be wider. Can't read anything. Anyway, go ahead.
Okay, sir. Oh, sorry, sir. Sorry for the inconvenience, sir. Sir, coming to the interaction, rice is the stable food crop for more than 60% of the world population. And in India, India is the second major rice producer in the all over the world. 40% of the country's total food grain production is about rice, and in India, West Bengal is ranked first in the rice production, followed by the UP. And then here comes the area and production and productivity of rice. Then next, even though it has the more important crop, due to the use of more chemical and minimum use of organics, it will lead to the mined out of nutrients, and it will cause the imbalancing of nutrient, and it cause the unsustainability to the lands. So in my topic, I'm taking two I'm giving, sorry for the inconvenient. Among the
please go ahead.
Okay, sir. Okay, sir. Okay, sir. So my topic is fully based on the organic farming. Among the organic sources, green manure and vermicompost provides more nutrient to the crop. So I'm taking this two factor for my research, and from this I'm going, my aim of the research is decomposition, to study the decomposition mineralization pattern of added organic manure in the organic paddy soil, then to study the effect of added organic and in with the relevant of yield and growth parameters, and under green gram. Then coming to the experimental sites, experimental site is located nearby seashore of Bay of Bengal, and it has the plain topography, and it comes under the 11th agroecological zone of 11th agroecological zone of India, and it is classified as PC2 coastal deltaic alluvial plain zone. It comes under tropical climate. Then coming to the treatment details, I'm taking two factors. One is green manure and green leaf manure. Another one is vermicompost. Green manure and green leaf manures are Daincha, Sunnem, Bungam, and Clyriceria. And factor 2 is vermicompost at 3 levels. Vermicompost at zero level, and vermicompost at 1 ton per hectare, and vermicompost at 2 tons per hectare. And along with that, one absolute control is kept for comparison. The next, this is the field view. in this before sowing of rice crop, in the consent in the consent plot, the rice crop were grown. The green manure crop were sown, and it was incorporated before the transplanting of rice crop, and green leaf manure brought from the nearby areas, and both the green manure and green leaf manures are applied in the field to the particular treatment plots. And next, vermicompost, the consent vermicompost treatment plant, the vermicompost are applied to the field. And next, manually, the incorporation was done by manually. And during this period, 10 days time period is given for the decomposition of added organic manure. From 10 days, we are taking the soil sample at day wise, and we are collecting, we are analyzing for an ammoniacal and nitrate and release pattern. This is the main field preparation of main field image. And next one is, this one is piezometer. For studying the complete nitrogen dynamics, we are going to install the piezometer in the field, and it is used to measure the nitrate loss from the soil. This is the installation of piezometers. It is 1 meter long and having 7.5 centimeter diameter PVC pipe with perforation at the bottom, and it is inserted below the root zone area of 80 centimeter depth. And from this, with the help of piezometer cup, after transplanting of rice crop, 14 weeks weekly intervals, we are collecting the samples and analysis for nitrate loss from the soil. And this one is ammonia trap. For the nitrogen balance, for working the nitrogen balance, we are selfly designed the ammonia trap for to evaluate the ammoniacal release, loss of ammoniacal release from the field. It is a self-made tripod stand with the porcelain basin, which contains N/50 H2SO4 plus methyl red indicator, and it is covered. It is air tightly covered to encapture the ammonia released from the particular area covered encapsulated area. Then this is the field view at trillering stage. This arrow mark shows the piezometer, and this arrow mark will shows the ammonia trap present in the field. Next, we are going to discuss with the data. Coming to the data, the ammoniacal end release milligram per kg release before transplanting of rice crop. Before transplanting of rice crop, the mean release of ammoniacal end was more in the glycidia and Dynesia. The mean release was more in glycidia and Dynesia. Then there is no significant difference was seen in the treatment plots, and the significant variation was seen in control versus treatment plots on 2nd and 5th and 8th and 9th and 10th day after the incorporation of green manure and green leaf manure. And then coming to the nitrate N, the mean release of nitrate N was higher in the SUNEP and vermicompost at 2 tons per hectare. The control versus treatment shows the marked variation during the 2nd, 4th, 6th, 8th, and 10th day after incorporation. The next, this is the graphical representation of ammoniacal and nitrate release. The release was more after the 9th days after the incorporation. The release was more when compared to the early stages, but the release was more in the glycidia when compared to other other green menus. Next, coming to the ammoniacal and nitrate release in the presence of rice crop, 14 weeks during the 14 weeks standing rice crop weekly intervals, we are taking the sample and analysis for nitrate nitrogen and ammoniacal nitrogen. The control assist treatment shows the significant variation during the first and 8th, 10th and 13th and 14th weeks after the planting. The ammoniacal N shows the variations, marked variation. Then coming to the nitrate nitrogen, the control versus other treatment shows the marked variation during 4th, 6th, 11th and 11th week after planting of rice crop.
Please wrap up now, quickly.
Sir?
Please wrap up, because 10 minutes is almost over.
Sir?
I mean, you wrap up, try to wrap up fast. Yes, please go ahead.
Okay, sir. Okay, coming to the loss of nitrogen. The loss of nitrogen as ammoniacal and nitrate form is presented here. The loss of nitrate nitrogen is more than the ammoniacal N. The higher loss was recorded in the glycidia treatment, then followed by the fungum treatment. Then during second week after transplanting, the control registered the significantly higher loss of ammoniacal N. And then coming to the growth parameters, Dainsha registered higher leaf area in higher plant height and leaf area index and dry matter production. Then coming to the yield parameters, Dainsha registered higher grain yield of 3,707 kg per hectare, and among the vermicompost level, vermicompost at 2 tons per hectare registered higher yield of 3,371 kg per hectare. Then star yield was higher in the Dainsha. Then coming to the, this is the representation of yield and diagrammatical representation of yield and then coming to the nitrogen balance. Nitrogen balance was calculated by sum of initial available N and added through the treatment organics and rainfall and irrigation water. Then the total loss were calculated by using N removed by the crop uptake, weed, leaching and volatilization. Then computed balance were calculated by total gain minus total loss. The net gain were calculated by post-harvest soil minus initial soil available N. Here we come to know that the highest positive net gain balance in Dainsha green manuring was recorded in Dainsha green manuring at the rate of 9.6 kg per hectare, and followed by vermicompost at 2 tons per hectare at the rate of 4.4 kg per hectare. So 4.4 kg per hectare of net gain of nitrogen. Then this is the diagrammatical representation of nitrogen balance. Then out of our interest, we go for the second crop in the cropping sequence of green manure.
Please come to the concluding slide. Please come to the concluding slide, because your time is over.
Okay. Conclusion. Dainsha and glycidia mineralized and release the higher nitrogen, even though glycidia having more nitrogen content and releasing pattern, it has more leaching and volatilization loss was higher in glycidia and fungum. So Dainsha was found to be a suitable green manure, and it contribute 39% of nitrogen. Similarly, the vermicompost at 2% per hectare will contribute the more yield towards the green gram. So we are concluded that the Dainsha plus vermicompost at 2 tons per hectare shall be advocated to the organic rice fellow green gram cropping sequence. Thank you.
Thank you. Thank you very much. Now open for discussion. Any question, comments, please? Well, what is the pH of the soil?
pH of the soil is 6.68, sir.
And you have transplanted rice, right?
Yes, sir, transplanted rice.
Do you expect a lot of ammoniacal loss of nitrogen in neutral soil on submergence?
No, sir. Loss is very minimum only, sir. Nitrate loss is more when compared to ammoniacal loss, sir.
Okay. Okay. Thank you. Thank you very much for your
Okay, sir. Thank you. Thank you.
Thank you. So we come to the end of the Early Career Research Award presentation program. Over to the organizers.
Thank you. Thank you very much, sir. On behalf of the organizer, I like to thank and express my gratitude to the chairman, Professor Shanial, and the co-chairmen, Dr. J.C. Tarabdar and Dr. J.K. Sundar Rai. And also, I like to congratulate all the presenters for beautiful presentation. I also thank all the participants for joining this session. It's a very important session where young researchers presented their findings of research activity.
Dr. Burman, how do we sit together or consult each other so as to grade the
one thing you can do, sir, you can discuss among yourself, among other co-chairmen, and suggest the one name.
How? In which mode? Do I ring them? I don't have all the phone numbers.
I'll request Dr. Sundar Rai to contact you, and he will take you in conference call. Then
and you please contact the other judges also, the co-chairmen.
Yes, sir. Yeah. Thank you very much.
Yeah. At what time, actually? At what time we will see it?
We'll inform, sir. We have to start the next session, the plenum lecture. We have a very important speaker for this plenum lecture 7, Dr. Anupama Sharma. He is a scientist F from National Institute of Hydrology, Roorkee, India. And for this session, I like to invite Dr. Mohammed Mainuddin, who will chair this session, and the rapporteur of this session, Dr. U.K. Mandal. He is the principal scientist from Central Soil Salinity Research Institute, Cannington. So before start this session, I would like to introduce you, the chairman of this session. Dr. Mohammed Mainuddin is working as principal research scientist with Water Security Program of CSIRO, Land and Waterways in Canberra, Australia. He has over 30 years of research experience in integrated water resource management and modeling of river basins, coastal water and salinity management, irrigation system performance analysis, agricultural productivity and food security analysis, socio-economic and livelihood issues related to water use, and impact of climate change on water availability, agricultural productivity, and food security. He has experience on working on several major river basins in Asia, Australia, Africa, South Africa, and has experience of working in Australia, Bangladesh, Netherlands, Thailand, Pakistan, and Sri Lanka as a resident. Now we invite our chairman to start this session. Thank you very much.
Thank you, Dr. Borman. Can you hear me?
Yes, sir.
Yeah. So good evening, everybody from Canberra. It is now 9:43 in Canberra in the evening. So as we are already late, I would like to get into the session directly. So our speaker in this plenum is Dr. Anupama Sharma. So Dr. Sharma did her PhD in IIT Roorkee in 1997, and since 1998 she has been working as scientist at the groundwater hydrology division of the National Institute of Hydrology. She led and handled major projects in India, and now currently she is the principal investigator of several prestigious projects, which is being as collaboration between India and UK government. She has supervised many students for master's and PhD thesis, and she has about more than 40 publications in international national journal, and she visited many countries including Denmark, China, Syria, Nepal, Sri Lanka, and United Kingdom. She will be speaking about water management strategies to mitigate saltwater intrusion with special reference to coastal Saurashtra. So I think the presentation session is for total for 30 minutes. So I would request Dr. Anupama to finish maybe within 25 minutes so that we can take a few questions in the rest 5 minutes. So Dr. Sharma, please. Can't hear you. Please unmute. Please check the audio setting.
Our video is on, but we could not able to see. Hello, Dr. Sharma, can you hear us?
You can check the speaker button and then click, and then there is options. So
it's on. Yes, it's not
either headset or the computer audio.
Madam, on the left of the Zoom panel, you can see a button. There you click join audio if it is not there.
I think it was coming that it was showing that it was mute. On mute. Yes, now please. Okay, it's keeps shifting.
Yeah, can you hear me?
Oh, now yes.
Yeah, now.
Okay, fine. So I'll be sharing my screen.
Yeah, please share your presentation.
Yeah, I hope my screen is visible to
Yeah,
all.
yeah, it's visible.
Okay, thank you. First of all, I thank you for the opportunity to give this talk on water management strategies to mitigate saltwater intrusion with special reference to coastal Saurashtra. In the classical sense, saltwater intrusion is used to describe the movement of saline water into freshwater aquifers. In a broader sense, saltwater intrusion is the upstream or the landward movement of saline water that causes the concentration of salts in the coastal system to increase above natural background levels. Now, the salinization of coastal areas, it is a global issue of serious concern because it reduces the potential productivity and the use of land and water resources. It may lead to changes in the chemical composition of natural groundwater resources. It spoils the quality of water for domestic, agricultural, and industrial use. It may lead to loss of biodiversity, loss of fertile soil. It will affect the agricultural yield and fishery industry, create health problems. So it affects many aspects of human life and poses a major hindrance to economic development of coastal regions. Now, how does saltwater intrusion occur in a coastal system? In many locations, the seawater entering through the estuaries of creeks during high tides, it may submerge large areas of cultivable land. This renders the fertile land saline and makes it unfit for crop cultivation. However, Saltwater intrusion may have serious repercussions when the intrusion occurs into the freshwater aquifer systems. Here, the extent of subsurface saltwater intrusion may vary from widely from place to place because of the variations in the hydrogeologic settings, the distribution of saline water, the amount of groundwater withdrawals. Now, these may lead to different pathways of saltwater intrusion into coastal aquifers. Now, this saltwater intrusion, as I've discussed, it may arise from, it may be a result of the lateral saltwater intrusion, which may be caused by the falling inland groundwater levels or the rising sea level because of climate change. It may be a result of the vertical downward saltwater intrusion, which is mainly from the saline surface water, which is carried inland by the tidal creeks and estuaries, and from the repeated submergence of the coastal land from the saltwater surges. Or it can be because of the migration of the pre-existing pockets of subsurface saline water. And again, this might be because of the vertical intrusion, the lateral intrusion, or ancient seawater that was deposited with the aquifer sediment. Now, the rate of saltwater intrusion along all these paths may be greatly affected by the groundwater pumpage that is happening in that area. So if you can see the figures here. Now here, when we are pumping the groundwater from the coastal region, it may lead to the lowering of the groundwater table here. Now, because in a coastal setting, the fresh water and the seawater, they exist in a dynamic equilibrium. And under natural conditions, because this saline water is heavier, so it tends to push the fresh water towards the landward side, and a sort of natural saltwater freshwater wedge is formed. And when the groundwater table goes lower, this saltwater wedge, it tends to intrude further into the freshwater coastal aquifer system. Now, this kind of intrusion, which is happening because of the lowering of the water table, it is basically passive intrusion. It might take years for this to be detected, and it is mainly density driven because of the high density of saline water. But when we are pumping large amounts of water, groundwater, from the coastal system, a reversal of the groundwater table might occur, or the piezometric head in a confined aquifer. The reversal of the groundwater gradient might occur, and this tends to accelerate the movement of the freshwater saline water interface towards the landward side. Now, this kind of active intrusion is gradient driven, and it might take hardly some months for the interface to reach the water supply wells. So now this figure illustrates the different types of stresses that a coastal aquifer system maybe experiences because of the urbanization and the agriculture. The water demands might be increasing, which disturbs the dynamic balance between the fresh water and the seawater. Because of the climate change and the sea level rise, the precipitation might be getting affected, which can lead to changes in the recharge to the groundwater system, and finally the change in the groundwater levels. And this might lead to the intrusion of seawater into the coastal aquifer. It might lead to decline in the groundwater available for the public supply, or it can change the groundwater discharge to the streams, wetlands. So these things might be happening simultaneously. So all in all, the coastal regions present very complex and unique management challenges. So now the effective management, it requires balancing the different competing demands, and it requires the use of extensive field investigations, long-term data monitoring, modeling studies, and development of consensus on proposed management options. So for suitable water management strategies, we can opt for different types of measures. Number one, monitoring, assessment, and modeling approach. Number two, behavioral and institutional approaches. And number three, the engineering measures. So the monitoring, assessment, and modeling approach, it involves the data collection analysis of the salinity in the system and the water levels and different aquifer parameters and the type of different crop cultivation, the groundwater withdrawals, and integrating the database, and then finally going in for the scientific assessment and simulation studies of the area. We can also go in for the behavioral and institutional approaches. Now, these approaches involve the water supply and demand management. Here we can limit the amount of groundwater abstracted. We can relocate the wells farther inland, or we can go in for water saving measures like increasing the irrigation efficiency. We can also opt for cultivation of more salt tolerant crops, or we can go in for usage of the blended water wherein we physically blend the fresh water with the saline water to provide water with acceptable salinity levels. Then they can also go in for coastal protection measures. Now in zones which are prone to seawater flooding and seawater sprays, we can go in for building of levees, dikes, and natural protection like dunes and mangrove vegetation to limit the susceptibility to salinization of the coastal system. Then we also have the institutional approaches like the regulatory approach, where we can go in for well registration and licensing. We can offer economic subsidies to individuals or farmers to invest in new technologies to manage the salinity. And we can also create awareness and training to the coastal communities. Now, among the engineering measures, now these engineering measures are the effectiveness of these engineering measures. It depends on the local conditions. Now, in case of surface channels, the control measures, these involve a construction of structures that physically prevent the salt water from moving past a certain point in the estuary. So here you can see this is the tidal regulator that can be built at the mouth of the estuary, or these are the local agricultural drains where we can have those tidal gates which allow the excess water to flow out through the agricultural fields into the surface channel, but the gates tend to close when the high tide is there. So it prevents the entry of saline water into the adjacent agricultural lands in the coastal system. We should also go in for minimization of the construction of canals that allow the salt water to migrate into inland areas. So these are some control measures for intrusion through the surface channels. Now, the control measures for intrusion into coastal aquifers, these involve the seawater barriers, like we can have the low permeability subsurface barriers and hydraulic barriers. We can also go in for aquifer storage and recovery, wherein the fresh water is injected into the aquifer during high supply season. And this fresh water is injected, suppose during the monsoon season, it is recovered during the low supply season by pumping out the fresh water. We can also go in for increased recharge by spreading the water in upland recharge areas, which builds up a healthy hydraulic gradient towards the seaward side, and this retards the saltwater intrusion. And in areas where we have the fresh water underlain by saline water, we can go in for the skimming wells, which are able to successfully pump out the fresh water from the freshwater saline water aquifer system. Now, this figure illustrates there some of the hydraulic barriers. This is an injection hydraulic barrier, and here we use coastal canals, trenches, infiltration fields, or injection wells to form a pressure ridge like this. And here we can, protect the production well supply field on the landward side by having this kind of pressure ridge through the injection hydraulic barrier. We can also go in for a pumping barrier here by having pumping wells all along the coastal stretch parallel to the coastline, and we can again protect the production well field. Or we can go in for a combination of the pumping injection well system and protect the well supply field on this side. Another alternative is the physical barrier, where we construct a subsurface barrier parallel to the coast. These are somewhat costly in nature, but the overall cost is offset by the low maintenance in the long run. So with this brief introduction about the possible water management strategies, I shall be now talking about the Saurashtra Peninsula in Gujarat. Gujarat is basically located on the west coast of India, and it has the longest coastline among all the Indian coastal states in the mainland, the longest coastline of about 1.15 kilometers. And here you can see this peninsula, it provides a variety of coastal features because of its varied physiography, geomorphology, and coastal processes. The central portion of this Saurashtra Peninsula, it is occupied by the Deccan Trap, which tapers off towards the sea coast. And this Saurashtra coast, it exhibits a number of cliffs, tidal flats, estuaries, coastal depressions, or these are the low-lying areas, which are locally termed as ghed areas. And we also have the sandy beaches, dunes, marshes. So all these numerous coastal features are present in the Saurashtra Peninsula region. And as you can see here, a number of rivers, they rise from the central plateau and they meander through the coastal plains in a radial pattern and meet the Arabian Sea. The aquifer system, if you look at the aquifer system of the coastal Saurashtra Peninsula, here you will find that it is mostly limestone and alluvial, but in the central portion, it is a Deccan trap, which is present. The rainfall in the region is mostly between 500 to 700 millimeters, although in some parts, like in the Junagadh region, the rainfall is higher. But the most of the region suffers from low rainfall, basically semi-arid region. And if you look at the land use land cover, most of the land is occupied by the agricultural activity. The yellow color, it shows the agricultural land. Now, if we go back to 1970s, in 1970s, the diesel pumps, they were introduced to the farmers for withdrawing groundwater for irrigation. Now, the introduction of these diesel pumps, they resulted in heavy withdrawal of groundwater, and the groundwater salinity as a result, it was first noticed in early 1970s. The crop production as a result was adversely affected, and a drastic fall in the per capita income of the farmers was observed. This disrupted the agricultural activity, and it forced a mass migration of local people and landless laborers to urban areas. The average growth rate of the population was, it became less than the state average, and even the milk production was affected because of the lack of green fodder for cattle. Now here you can see all along the coastline, this is your Saurashtra Peninsula. So all along the coastline, the villages were affected by the coastal salinity. Now here, this coastal salinity was a combined effect of the seawater ingress due to the groundwater overdraft, because of the tidal water incursion through the estuaries, the saline water percolation in the low-lying marshy lands, the inherent formation water salinity, and the saltwater sea sprays. So we conducted one study in this Minsar Basin located in this Porbandar district. So now, as a result of this problem that was encountered in the early 1970s, the government of Gujarat, it set up a high-level committee to look into the problem and for possible remedial measures. Now, the committee, it recommended an integrated approach, which involved, as I was discussing earlier, the scientific assessment, modeling, and data collection activities, the institutional and behavioral measures, and also the engineering measures. So they recommended hydrogeological surveys and construction of structures to conserve the rainfall runoff and enhance the groundwater recharge. This involved the storage structures, the groundwater recharge structures, and the tidal regulators on the mouth of the estuaries. Additionally, they also recommended coastal shelter belts to reduce the impact of sea sprays on the soils and the water sources of the region. So, as per the recommendation of the committee, they recommended the construction of check dams in the upland areas of the coastal Saurashtra Peninsula, bandharas on creeks and estuaries. Now, bandharas are basically solid walls with non-gated structures, and the level of the height of this wall is 1 meter above the tide level. They also recommended the freshwater reservoirs in the Ghid area. Now, Ghid areas are again depressed lands. So they recommended the construction of freshwater reservoirs in the Ghid area, and also the construction of spreading channels parallel to the coast. So here you can see the picture of a bandhara, and this is a spreading channel all along the coastline, parallel to the coastline. So if you look at the Minsar Basin of the Saurashtra region in the Porbandar region, here you have the Minsar River, which flows down from these hills in the Barda Hills, and here all the water is getting collected in the low-lying Ghid region here. Now, based on the geomorphology, this region is classified into Barda Hills, the coastal plains, that is the low-lying flat mudland. This is the Ghid area, and then we have the coastal ridges here. Now, the Barda Hills, here we have very steeply undulating topography, and it is occupied by Deccan Trap Formation, but the weathered zone is quite thick, up to 30 meters. And the Ghir area, this is the deltaic region of the Minsar River. The inland basin is in shape of a saucer because of the higher topographic elevations of coastal ridges. but the area is devoid of any proper surface drainage. And whenever during the monsoon season, the fresh water runoff is getting collected in the Ghed area. But what happens during the high tide, because of this connection of this Ghed region through this estuary, the salt water, it enters through this estuary into the Ghed region, and it spoils the quality of the fresh water that is stored as a result of the monsoon runoff. So although this Ghed region is not having high permeability, it is a very clay kind of formation here. But because of this this soil water intrusion through the estuary, all the soil, this fresh water degrades, and it becomes of no use for the general public. Besides these features, we also have coastal ridges in the coastal plain. Here we have the beach sand and the millilithic limestone along the coast, and here the topography is gently undulating. So if we look at the geology of the region, here the Ghed area, this is the Ghed area, this is covered by a blackish brown clayey soil with thickness between 2 to 7 meters. And here near the coast, parallel to the coast, we have the millilithic limestone, and the maximum thickness of this millilithic limestone is around 50 meters around this region, Madhavpur and this Odar and Ratanpur villages. And this millilithic limestone is exposed near the coast, and below that we have the Gudge limestone and clay formation, and below that we have the Deccan Trough, the salt exposed in the inland areas. So here the millilithic limestone, it forms a potential ecosystem in the coastal belt. So parallel to the coastline, this is a cross section parallel to the coastline. So here we have the millilithic limestone, which forms a potential ecosystem parallel to the coast. But if you look at the cross section perpendicular to the coast, you will find that the Deccan Troughs, these are the most extensive aquifers, but these are quite poor aquifers. It is basically the weathered zone of the Deccan Trough, which forms a good aquifer in the upland areas. Now, because of the recommendations of the high-level committee, they constructed these bandharas. As you can see here, these bandharas were constructed at the mouth of the estuaries, and because of this, they were able to conserve the fresh water runoff, which was there collected during the monsoon season. And they also constructed some radial canals from these fresh water that was this reservoir. And these canals were used for irrigating the nearby lands, because here the groundwater was inherently saline. So they used the reservoir schemes to irrigate the nearby coastal land. Now, one feature of these irrigation schemes is that because of this, conservation of the fresh water runoff, the farmers, they are able to store the fresh water and use it for cultivating the agricultural land up till February, up till the month of February. Earlier, this fresh water was not available up to this extent, like up till the month of February. But because of this construction of the tidal regulator, the fresh water was present in the irrigation reservoir, the irrigation scheme. And it was only in the month of April that you can see the fresh water has been exhausted. But during the low rainfall year, as you can see here, this is the scenario for October 2012. Here you can see not much water has been collected. So basically in a good rainfall year, the farmers have been able to tap the monsoon runoff. It is only the low rainfall years that still pose a problem for the farmers in the region. Moreover, the spread area of the irrigation reservoirs, it shrinks with the passing months as we approach the pre-monsoon season. The salinity in the reservoir, it also rises, but still up till the month of February, the salinity is good enough for irrigating the nearby crops. Now, the direction of the groundwater flow, it is in general towards the sea, as you can see here. The direction of the groundwater flow is towards the sea. But during the low rainfall year, that was the year 2012, a reversal of groundwater hydraulic gradient occurred near the coast because of this low recharge. So here you can see how the water table the reversal of the gradient has occurred here. So the maximum, on the water table, it is now below 20 meters below the mean sea level here. So it is during such low rainfall years that the problem of seawater intrusion, it gets, enhanced. And because of this, the salinity encroachment problem might be there. But otherwise, during the normal rainfall years, this is the scenario. So during the subsequent year, that is in 2013, the post-monsoon year of 2013, post-monsoon month of the 2013, we found that again the water table was able to recover to its original position. But during the low rainfall year, this was the scenario, and which can lead to saltwater intrusion problem directly from the sea.
Please conclude.
Yeah. So now again, these are the total dissolved solid. These are the TDS contours, the salinity contours, and you can find here that at the depth of less than 8 meters, this is a scenario, and depth of more than 15 meters, the salinity is much more. So now, what is the impact of water management strategies on the crop yields? Here you can see during the years 77, 78, the Kharif crop and the Rabi crop both were was quite low. But during the year 2008 and 9, similar rainfall, the Kharif crop and the Rabi crop both are enhanced. And here you can see, if we compare for the year 72, 73 and 2012, 13, these are the low rainfall years. So even during the low rainfall years, the crop yields have increased. The area under crop yield crop has increased. And similarly, during the normal years also, the area under cropping, the crop land has increased. So this kind of investment in the structures, the bandharas, the check dams, and the spreading channels, it is present all along. The spreading channel has been constructed all along the Saurashtra coast, parallel to the coastline, and the villages falling under the spreading channel and the Barda Sagar schemes, they have, like here in the Porbandar region, they have witnessed an increase in the area under irrigated crops by more than 79% and 46% as per the saline ingression protection circle. So besides this, the coastal shelter belts have also been employed to reduce the direct and indirect impact of sea sprays on the plants and water sources. And these act as effective barriers to reduce the damage from the salty winds and provide shelter to the coastal line. And moreover, the farmers, they have also gone in for mixed kind of plantation in the coastal shelter belts, and that has also increased the crop yields in the coastal stretch. So basically, the coastal communities in the Saurashtra region, they have to combat the twin problems of recurring drought and groundwater salinity. However, the construction of bandharas, it has enabled the conservation of surface water runoff from the catchment of the Minsa River and Barda Sagar, and it has prevented the seawater ingress through creeks in the inland areas. Moreover, the surface water irrigation scheme in the low-lying glade regions, they have facilitated the access of fresh surface water for irrigation to the farmers in the glade area, and it has enhanced the groundwater recharge to the radial canals sticking out from these reservoirs. Further, the spreading channel, it has aided the groundwater recharge, and the water for crop cultivation through lift irrigation in coastal strip is there available for a longer time. And this feeds, the spreading channel feeds the surplus flood water from one reservoir basin to another reservoir wherever the rainfall is scanty. Further, the check dams and percolation tanks, they have augmented the groundwater recharge, maintaining a healthy groundwater hydraulic gradient towards the sea, and it provides additional groundwater during the drought years. So overall, the water suitable for irrigation, it is available for a longer period over a larger region compared to the previous decades, and a gradual change in the cropping pattern with more farmers opting for cash crops is witnessed in the region. The suitable coastal management, water management, major expansion in irrigation, implementation of drip and sprinkler irrigation. Now, these have boosted the agriculture economy in the region. So I would just simply like to acknowledge the NIH team and the Hydrology Project Phase 2, a part of the work that I've shown here It was carried out under Hydrology Project Phase 2, GWRDC Gandhinagar and SIPC Rajkot. So thank you all.
Thank you, Dr. Sharma. This is a very informative and presentation with a lot of information and how the coastal saline intruded area can be rehabilitated. It's a very important piece of work what you have presented. So we are nearly the end of our time. So we can take maybe one burning question if anyone has. Please raise your hand if you have any burning question. Otherwise, I would request to contact Dr. Sharma if, for any detailed question you may have. Anyone has any question?
Yeah.
Yes, please, Dr. Tyagi.
See, in theory, the efficacy of these measures, whether it's Bandara, whether it's check dams, is well established. What we are interested in knowing is what is the quantitative values that have been established through this study.
Yeah, that has been carried out. So of course, I didn't present in great detail, but the estimations were there in the beginning by the committee. Later on also, we have been trying to estimate what, because that was done prior to the works that were taken up by the committee. Later on during our study also, we have tried to establish what has been the impact of the additional measures on the groundwater recharge occurring in the system. And also the salinity issues, how they have been reduced. So that also we have tried to study.
Thank you.
Thank you. I think there is no other questions. So thank you, Dr. Sharma, for your very nice and excellent presentation. And with this, I hand over to the organizer for the next session.
Okay. Thank you, everyone.
For me,
it's my present duty to thank Professor Moinuddin and Dr. Sharma for their excellent cooperation and support. And the lecture was very informative, very educative. Not much of work has been done in this particular country on the seawater intrusion in particular. I think this will make the way, because in the morning itself, there was a very frightening picture given from from Anna University in Tamil Nadu. Their groundwater table has receded even to the extent of 14 meters in some places. Of course, the study was not exhaustive for the whole country, and that makes the seawater intrude into the coastal areas. So that was very frightening picture that has taken place for various reasons. The groundwater table recedes to that extent, and not many of us were knowing about it. So thank you very much. And then this is a very important area to ponder upon for future coastal soil salinity management in particular. Thank you very much. Thank you, both of them. And thank you very much.
Thank you, sir.
Okay.
Thank you, all of you. Now I will start our next plenum lecture that will be delivered by Professor T.G. Sitaraman. He is the Director, Indian Institute of Technology, Guwahati, India. And for this session, I'd like to invite Dr. N.K. Tyagi as the chairman, and this session, the reporter for this session, Dr. Ranu Rani Sethi, is the principal scientist, Indian Institute of Water Management from Bhubaneswar, India. Before starting this session, I would like to introduce our chairman, Dr. N.K. Tyagi. He is the former director of Central Soil Salinity Research Institute, Karnal, and he was the former member of the Agriculture Scientists Recruitment Board, New Delhi, India. He is presently independent consultant for inland water and environment. He is a recipient of many prestigious awards from India and abroad. He is the fellow of many societies from India and other organizations from abroad. His main research area is the water resource management, salinity, and environment. Now I would like to request Dr. Tyagi, the chairman of this session, to start this discussion.
Okay, am I audible?
Yes, sir.
Yes, yes.
Well, President Sen, Thank you very much for inviting me to chair this session, and thank you for the introduction, Dr. Burman. This evening, I have a pleasant duty first to introduce our learned speaker, Dr. T.G. Sitaraman. He is the present director of IIT Guwahati and is an eminent scholar, educationist, and institution builder par excellence. An alumnus of the most prestigious engineering institution in India, that is Institute of Science, Bangalore, and the PhD from Waterloo University, Canada. Professor Sitaram has a long career in the Institute of Science, Bangalore, and he rose there to the position of the chair professor in the area of energy and mechanical sciences. He has been the founder chairman of the Center for Infrastructure, Sustainable Transport, Urban Planning, ISCAR. His eminence in the field of geotechnology is internationally recognized. He is an honorary professorial fellow at the University of Wollongong, Australia, and also the distinguished professor at the International Innovation Center, Hangzhou University, China. For his lifelong contributions to the field of geotechnical engineering, he received Kuckelman Award of IGS. He is the editor, or the chief editor of the International Journal of Geotechnical Earthquake Engineering, published from USA, and also the editor-in-chief of the Extended Transactions in the Civil Engineering Singapore series. He is fellow of many prestigious academies, societies, including the fellowship of the Institution of Civil Engineers, UK, fellow of the American Society of Civil Engineers, and also fellow of the Indian Engineering Institution. Well, gentlemen, our speaker is also the promoter of the Sarovar project, which envisages construction of a chain of coastal reservoirs. To propagate this idea, he has established International Association of Coastal Reservoir Research, ISCAR. Dr. Sitaram ISCAR, that is our Society on Coastal Agriculture Research, is a vibrant society actively involved in addressing the problems of coastal agriculture. And as I understand, water and climate, the common issues being dealt by ISCAR and ISCAR, of which you are the founding president. And this leads to a scope of close collaboration. Now, gentlemen, I have great pleasure in inviting Professor Sitaram to please deliver his lecture. The time allotted is around 25 minutes, and which will be followed by question and answer. Professor Sitaram, please.
Namaste.
Namaste.
Chairman, Dr. Tyagi,
yeah,
and the President, Professor Sen. So first of all, let me thank the organizers to invite me to give this talk on International Symposium on Coastal Agricultural Virtual Mode. Plenary lecture. You might ask a question, what is civil engineer is doing with an agricultural engineering group? So I would like to start with a punchline of my talk. Is India running out of water? Actually, my punchline is, in fact, water is running out of India. So I will demonstrate through data and then say, and why we need to go for a coastal reservoirs, and then what has happened in the building of large dams by India for storage of water. Ladies and gentlemen, the Global Risk Perception Survey conducted by the World Economic Forum reports that the highest level of societal impact over the next 10 years will be from water crisis. Water stress has caused countries around the world to consider ways to mitigate the impact of increased population and as well as climate change. More than 50% of the world population live within 200 kilometers of the coast. And 75% of the mega cities, which have population of more than more than 10 million, are located close to the sea or in the coast. big pressure on land, water supply, and other infrastructure development in coastal areas, and conservation of coastal environment is also interest to many, caused really an issue for the sustainability of water. So water, food, energy is a nexus, all of us know. So in that way, it is connected to coastal agriculture as well. Procedures from the government of India for the development, sustainable development of coastal areas and conservation of coastal environment, the government of India has approved the new coastal regulation zone notification in 2018. Procedures have been streamlined and simplified for CRZ clearances. This will add to creating additional opportunities for affordable housing, boosting tourism along the coastal zone. A national prospective plan, NPP, of the comprehensive development of 7,500 kilometer coastline of India with 14,500 kilometer potentially navigable waterways and the maritime sector has also been prepared by the government of India. That is called as Sagarmala concept. And along with that, Honorable Prime Minister has also put Bharatmala, connecting these ports and the inland waterways. So now we need to look at something beyond that. That's what my proposal is on Sarovar Mala. Okay, the link of Sarovar Mala, because I will highlight to you why this Sarovar Mala. Okay, and how to really manage the coastal zone in terms of water resources and their potential uses. And let me share my presentation. Are you able to see?
Yeah.
Okay.
Bring it to the presentation mode, please.
Yeah, I did that.
It is.
Able to see?
Yeah.
Okay. So my presentation, I divided into the following 5 topics. I'll try to cover within 20 minutes so that, we can some debate. So let me take you directly. So my talk is little more on technology, innovation, and ideas in the civil engineering area to create the coastal reservoirs. So as all of you know that Sustainable Development Goals, we are only left with 10 more years to fulfill the SDG goals of alleviation of poverty, and even if you are only interested in clean water and sanitation. So, but if you look at all the aspects, every SDG goal is touched with water. Water is a key. But however, the goal 6, the ensure availability and sustainability management of water and sanitation for all, talks about a specific on the water quality and water issues. So basically each goal is important. However, water is very critical. That's why I put SDG 6 is very important. So we need to move from shortage to water security. See, today we have seen newspaper readings saying that Chennai is running out of water. Okay, Bangalore is running out of water. Delhi is running out of water. But how are we going to move from water shortage to security? So the problem, we need to identify the terminologies. So let me tell you, see, water in terms of water challenges is, one is availability, another one is quality water availability and the accessibility, because water is not everywhere in every part of the country. Okay, so the water scarcity is about the availability. Is it really? Water stress is basically having a good quality of water accessible to all people. So that may be true. You might have a water stress, but definitely, do we have a water scarcity? A country having 1,000 millimeter average annual rainfall may be distributed because of climate change and everything. It is not changed over a period of 1,000 years, 100 years, at least 110 years I've looked at it. I'll show you the data in the next slide. So the status of water resources in the context of climate change, definitely there is an effect, but nowadays most of the coastal area receive large amount of rainfall in the order of even 3,500 to 5,000 millimeter rainfall. So there are many areas have become droughts more intense and increase global flood risk as well, because some of the areas keeps getting floods. So climate change, water, and sustainable development are the very linked topics which are very critical. And another area is world agriculture by salinic and sodic soils wherein you can see the number of the 60% of the cultivated in the coastal area is very highly salinic and sodic, as the previous speaker also highlighted. So worldwide distribution of salt affected areas is also quite large and it is increasing. So the climate change scenario trends in water availability, if you look at it, we are having, almost like a blue, where there is no shortage of really average water availability for us. So the world average annual precipitation, if you look at it, entire India is more than 1,000 millimeter annually. So definitely there is maybe a water scarcity in terms of good quality of water available to every citizen, but there is no shortage of water, ladies and gentlemen. So we need to look at, but the projected water scarcity by the IWMI, it shows most of India except leaving some coastal areas. So we do have what is called as economic water security along the entire coastal of India, 7,500 kilometers or so. Interesting to note that coastal areas, economic water scarcity has been shown here. Water quality and demand, definitely our demands are increasing. Water demand is projected to increase by 55% globally, and even in India also it is increasing. The increase in demand will also come from manufacturing, electricity, and domestic usage. It's almost 130%, 140%, and 400%. Because if you look at manufacturing, scale of investment is ought to increase significantly for water infrastructure as well. So the transboundary water issues in India are quite large now. See, because as you know, that water is a state subject. So water center is only managed in case of interstate disputes. We do have too many interstate disputes to handle, and I don't know when it will be solved. I don't see an end of solving interstate disputes soon. And then environmental damage. So interlinking of river through the difficult terrain of India inside India is very, very challenging. We might have done that connecting Krishna, Godavari closer to the coast, but I don't think we will be able to cover our Dr. K.L. Rao's vision of connecting Ganga to Kaveri. There is no way. There is no way. Impossible. So what is the next step? See, we need to look at large quantity of water storage. See, as I told you, we do not have shortage of water. We have a shortage of storage. I will prove it to you in a little while. So we have about 4,000 billion cubic meter of water through rainfall. That's only one source actually. See, we do not see whatever we talk about tanks, water bodies and all that, they're all only storage bodies. Water source is only one, rainfall, which through that we get annual precipitation of 4,000 billion cubic meter of water. We have an accountable total surface water body, 690 billion cubic meter of water. This is not my statistics. This is the Central Water Commission statistics. Anybody can go to their website and find out. So the story of India is we have 400 rivers in total with 25 basins, 7 most large basins. And please look at 82% of this runoff goes to religiously every year during monsoon to the ocean. And I'm not talking about stopping all of it, maybe 5% of it. 82% of the rainfall, what we receive, simply joins the ocean. We might have to store another 5% because I will show you with very large dams, what we have constructed since independence, we are able to store only 8% of the water of the annual rainfall, 8%. So the rest of the water, maybe another 8% is going to the hard rock and also some surface small water bodies in the villages and towns. And then 82% of the water is simply joining the ocean. The story has not changed, ladies and gentlemen, since Arthur Cotton built a barrage across Godavari. He made a very beautiful remark to Britishers in 1800s, while before building the barrage in Godavari, across Godavari, very close to the coastal. He said, he argued actually for the British, saying that 1 day outflow of Godavari is equivalent to 1 year outflow of Thames. You can see that. That's the kind of quantity of water. 1 day outflow of water of Godavari is equivalent to 1 year outflow of water of Thames. So that thing has not changed even today, ladies and gentlemen. That means, but only thing is, times have might have crushed. That means earlier 5 months monsoon is to come. Now it may be about everything in 3 months, and some very short, very intense rainfall are coming, maybe in 2 hours, 3 hours. All that is simply flowing into the ocean. And majority of the rainfall is also happening now. See, if you're seeing Kerala and then recent floods of Kerala and even coastal Karnataka and coastal Maharashtra, large amount of rainfall, close to about 5,000 millimeters is happening, and most of them are under flood every monsoon, and it's very risky for us. So, as I told you, the annual rainfall I've plotted from 1901 to 2000, almost 19. You never, not even one single year, it has gone down below 1,000 millimeters. This is the annual rainfall in India in millimeter. So 7 major systems, if you look at the drainage and the average discharge, quite large, ladies and gentlemen. But again, this large quantity of water happens only during monsoon. So what has happened? Why this such a large flow? Why it is not holding in the land? Because I think I don't need to explain that to august audience, because all of them know, because most of them are agriculturalists. That is a very large area. With increase in population, water demand is also increased. But due to soil erosion and siltation, water bodies lose their capacity to store water. So degradation of forest, increased soil erosion have reduced the resident time of water. This is a very key aspect. They have reduced the resident time of water. We need to hold the water inland, not just building large dams. So if you can see the rivers and tributaries, every river is almost similar, except some gradients are steep, some gradients are not. You see, one is I'm talking about, we can divide that into low upper course and middle course and lower course. What I'm talking about is the coastal area is the lower course, where flow are low velocities, lateral erosion dominates. There are wide channels, extensive floodplains, braided channels, levees, oxbow lakes, meanders, deltas are all comes under that area. So, but where are we building our large dam? Majority of them, large dams, are in middle course or in the upper course. Even the storage, availability of water for you is not the entire catchment. See, if you are looking at something storage very close to the coast, your entire catchment is available to you. Unlike the dams, interior dams, where the catchment is only smaller, and you might also not allow the lower riparian people not to allow the water. So conventional rainwater harvesting section, Indians knew that they need to store water because rainfall is only 4 to 5 months in India, another 7 to 8 months we have to survive on storage. That time immemorial, Indian farmer knew about this. At that time, population was smaller. They adopted very beautiful, ahar pines in West Bengal, Baudis, Tankas, and some of them are maybe for drinking water, some of them are maybe for agriculture, but they are all very small storage things. Then India, I heard somebody was talking about check dams, diversion weirs, bandaras, all of them, very unique contribution of Indian farmers into charuvus. They're called in a different languages, different areas, something differently. So the beautiful, Bengal inundation channels were very beautiful concept that time to use the flood water. See, today we don't consider flood water as a resource, but what I'm talking about, flood water should be considered as a resource of water, and we need to store them. So, I mean, even in some of the areas like Kerala, Surangas, and all this, plenty of, so whether it is Nalla bands, contour trenches, percolation tanks, subsurface dikes, sand ramps, infiltration wells, so you can go on naming, but all of them store very, reasonably smaller quantity, maybe for a village or a small population habitat. But if you want to look at a kind of growth, what has happened in India, we need, I will skip some of these pictures so that, I can go into my topic of forestation. All are important. All are important. So we need to now look at, as I told you, interlinking of rivers or interbasin transfer is a big no-no. Store water more in inland reservoirs. I will talk about this in next slide. How many we have done it since independence? Is there any space left now? Okay. And interlinking rivers is difficult. Replenish groundwater is a very, very important point. We need to do that through the steps that I've just described and time memorial. And desalination from seawater, I think it's a foolishness to leave good quality water into the ocean and then take the same water and clean it up. It may be for Israel, it may be for UAE. It's an ideal because they do not, their annual rainfalls are smaller. But for India, leaving such a good quality wealth of water into the ocean in 3 months, and in another 7 months, you take the same water and start cleaning it up with a very heavy cost of energy and also pollution. Also, desalination is not a very clean technology. So finally, I am talking about conserve the flood water which joins the ocean in the coastal areas. It need not be in the ocean. It could be even inside. It could be closer to the coast. It could be even in the ocean. And have this idea, it will actually develop flood waters. Okay. So the coastal reservoirs are the key. So let me tell you the large dams, ladies and gentlemen. So since independence, when we got independence in 1947, we had 300 large dams. All of you know the definition of large dam, which has a 1 million meter cube of water, or the water body, dam, which is 15 meters or tall. There are many definitions as per the International Committee of Large Dams. But such dams were there, 300 in 1947. Do you know what today in 2021, how many? We have built more than 5,700 large dams, and India ranks 3rd in the world in dam building after USA and China. After building all these, what is that we are storing? We are storing less than 10% of average rainfall received in the country. So that means still 82% is going to the ocean. And we want to see, after doing 75 years, we have increased only our storage, maybe about 3%, building large dams. So we might have to increase maybe another 5%. We will solve all our problem actually. But so there is no shortage of water, ladies and gentlemen. There is a shortage of storage. So we need to still do the storage. Where are we building now large dams? Unfortunately, in the Northeast. 300 large dams we are building in the Northeast, very close to Guwahati. And most of them are in the zone 5, earthquake zone. And one more thing I want to tell you as a civil engineer. See, the dams what we have built using concrete are not really going to last longer. See, life of concrete is only maybe about 50 years to 60 years. I mean, if you extend its life by some treatment and other things, maybe 100 years. Beyond that, what are we going to do? Are we going to remove Bakranangal Dam and rebuild the dam again there using different material? I think you need to question this when we are building very large dams, and also think about how to really, otherwise, they start leaking, huge leakages, even repair it, maybe another 10 years. It's like putting a stent into your heart valves. So you can increase maybe 5 years, 10 years, but we can keep counting. So what my thinking is, we need to look at something beyond the concrete, something beyond large dams. So when Prime Minister Nehru inaugurated the Bakranangal, he said modern temples of modern India are the large dams. I think he was right at that time, maybe when we had only 300 large dams. But today, after building 5,700 or 5,000, including 300 dams in the Northeast, if you add 6,000 large dams, where is going to be the next temple of India, modern India? We don't have any space internally. And with the kind of environmental challenges and population growth and the requirement, I think we are lack of any storage area in the inlands. And also, as I told you, because of climate change, rainfall has shifted to coastal areas. People are living in coastal area. Why don't we look at a solution around coastal area and coastal aggregates? Because we need to increase the food production. I will also talk about that. The storage in the coastal area is 20 times more than the demand we can create. So this is our first book, new book on sustainable water resources development using coastal reservoir. And the first author, with 7 authors, we have written it internationally. And this comes from Elsevier. It has just appeared last August of 2020. Please have a look at this. This is a very interesting book in the Elsevier. It's about 300 pages. So what is a coastal reservoir against dam? Coastal reservoir is unlimited in the close to city or close to the coast, and which is a very low pressure, because you don't need to build like a very large dam, so you don't require a concrete to build it and limit their life. By density difference, it will work, and it is a pollutant. Definitely, we need to take care of it. So there is a 2 generation of coastal reservoirs. I'll talk about it. So Where are the coastal reservoirs? Existing one. Netherlands built it as early as 1932 with 30 kilometer long, but they did it for flood control. India, Tanimukam Band, many of agriculturists know in Kerala, they have used it, but today it is not that much functioning, but there are a lot of salinity getting into through Tanimukam Band. It is for agriculture. South Korea, Hong Kong, China, Singapore, United Kingdom, list goes on, because we have, after we started the International Association Coastal Reservoirs, large amount of coastal reservoirs we have come across, and the Japanese and everywhere, and we have, even in India, Gulf of Kambat, Honorable Prime Minister Modi, when he was the Chief Minister of Gujarat, and now the tender is out for Gulf of Kambat, what is called as Kalpasar project, Kalpasar. Okay, please go to the website, any Google, Kalpasar project, you will see the details of the entire project, which is going to irrigate the entire Kutch area through the contour canals from the Kalpasar project, which is going to be the largest water body storage, but it is under projection. So anyway, this will be a first generation coastal reservoir. Is if you close the entire mouth of the river, which is a very dangerous thing, but most of the older reservoirs are like that. But what I am proposing is the second generation coastal reservoir, where you do not need to block. The water will be continuously, bypass only when there is a flood water, very reasonably good quality, clean, very less saline water coming during the monsoon. You can store in the second generation, either inside, close to the coast, or at the edge of the coast, or inside the ocean, where you have a lot of erosion problems because of the ocean erosion. We can identify, so we can bypass the polluted water and store clean water. So the salts also will go and join the ocean. There is no blockage. Second generation coastal reservoir is what we are proposing, and that is the Shanghai's experience. Chinese have built a beautiful, I've been there twice, I was really impressed. 70% of the water for Shanghai city comes from one small reservoir called the Chinkosa Coastal Reservoir, constructed in 2008 and started functioning in 2010. That means they took only 2 years to build about 40 kilometer long earthen embankment with geosynthetics, and coastal reservoir, what you are seeing at the bottom, is ready, and which will supply 70% of the drinking water. All around is a salt water. Please note this, ladies and gentlemen. This is a delta of the Yangtze River. So all around is the salt water. This is a fresh water. They have a tunnel from here to Shanghai city and take the fresh water and supply. It's almost clean, and there are new wetlands have created so around this water body. And this is not a new concept in China. Chinese had Toshan because most of the China is in the coast. So about 1300 years old, they have formed a coastal reservoir which irrigates about 120 kilometers square. And then Mulanpi is about 1,000-year-old coastal reservoir with spillways, sluice gates and everything, and prevent saltwater intrusion, store fresh water. And the one in Afjaluk in Netherlands is across the Wadden Sea. The dike is created. You look at the road on this dike, it's almost like a high-speed 40 kilometers long dike, which can be used as a 6-lane highway to connecting two islands. And new fresh land is created because of this. Otherwise, earlier, always this used to be flooded zone in Netherlands. Okay. And this is the Afjaluk Izalmir store water bund. This bund is 32 kilometer long, about 90 meters width, and 7.25 meter high only. So construction of large coastal reservoirs in Hong Kong. This was a story in 1960s. They used to also carry water using bottles and dabbas. And today with Shipuk, Highland reservoirs and Plover Cove Reservoir, all of you know that Hong Kong is an island. It's a small country. I mean, not even a country, actually, it is now part of China. So small city, you can say, but they have 3 reservoirs. After that, there is no shortage of water for them. Okay. So Marina Barrage, many of you might have seen, is a first generation coastal reservoir constructed by Singapore, which supplies 15% of Singapore water. You see, this is the only 300 meter only dike. It's a technology intensive, which is a concrete dam which can rotate actually. This is a dam which is a steel gate, concrete gate, which can rotate. 9 numbers of such hydraulically operated steel crest gate, put it on a concrete base, is about 350 meter wide channel. Is a fantastic concept. entire Marina Barrage Bay. But Singapore can do this because Singapore can restrict all industry not to pollute the water of their streams. But India cannot do that. So first generation, closing the bay is not a solution. Second generation coastal reservoir is an ideal solution for India. So, and look at the coastal zone areas in Singapore, very close to the water body. They have built huge, beautiful conference center, hotel, shopping complex. It's a small country that can manage. But we are still debating on the coastal regulation. I think the new zone regulations. This is a beautiful, before 2005, Marina Barrage, after 2005. One side is the salt water, one side is the fresh water. So similarly, I can show you clearly some of the case studies of Simangam Wall. I'll not get into, this is a dam in Korea. One side is the salt water, one side is the fresh water. Okay, these are all first generation coastal reservoirs. The technology used to construct this also is not new. It's very simple, quickly buildable, using geotextile bags, geotubes, and geobags. So it's a very simple technology. Use the same sand bed from the bottom of the sea to create your geotextile tube filled with sand and create the tubes like this and build a dam. So these dams are smaller height, not much. One side water, salt water, one side is the fresh water. With geosynthetics, today's technologies allows not to allow mixing of these waters, can be very fantastically. No harm to the river basins or alteration because these are the lowermost. That's why I call it is a downstream water management of rivers. No disturbance to forest cover or submergence of land, no physical displacement of people, because Sardar Sarovar, many of you know, we have taken almost 60 years really to build because many areas were submerged, many villages have to be shifted. So that problem is not there and quantity of storage is very large in coastal reservoir. It could be equivalent to twice the quantity of what Sardar Sarovar is storing. Impounding on land, and coastal erosion can be minimized. Groundwater recharge also happens in the coastal area. Saltwater intrusion is also stops because of this. So many advantages are there. After our concept through International Association Coastal Reservoir, UN Water has actually included our concept of storing, developing floodwaters into their document, Water and Climate Change. Some of you can see that. You can Google WWDR 2020, which already covered. The beauty of this concept is we can generate solar energy on the coastal reservoir, because the water depth is very small. Tidal energy we can generate, roadways, and then freshwater fishing, deep water fishing, seawall. So the entire, and new land appears. So because of this, there will be a total development of coastal development, and challenges are also there. I'm not saying there are no challenges. Challenges are saltwater intrusion, pollution control, algal blooms, sediment accumulation, ecosystem imbalances. All of these can be handled if you adopt a second generation coastal reservoir. If you don't go for a first generation, most of these can be handled in the design and operation of the coastal reservoir. Let me come to agriculture, last 2 minutes. See, all of you know that I don't need to highlight this. Majority of water utilization is in the agriculture. So 82% for a competing water resources of a middle income country like India, we are close to about 8 to 9% domestic usage, about 10 to 11% is the industrial usage, but rest of it is agriculture. If you teach our agriculturists, develop revolutionary scientific usage of water, I think fantastically we can solve the water issues problem very efficiently. That is what we need to do. So we may be looking at newer kind of rice, what Japanese or Chinese have done. I think Indian rice people also have done quite a bit of seawater rice with the brackish water storage. They're already very popular in China. Okay, and no agriculture without water, no agriculture without land. So because of this coastal reservoir, we can create both. Okay, affordable agriculture water is crucial for us. So seawater rice, as you rightly said, is it the future of food security? I do not know. I think some of you have to answer that because you are the experts in this. So let me take you quickly to my conclusions. I don't know what happened. Yeah. So I'll just show you the last my case study on Kalpasar. Please note this. This is the Gulf of Kambat, okay, Gujarat. And it envisages of building a dam, okay, from in the Narmada distribution canal, which is here below. And they wanted to, Narmada River is right here. Kalpasar is here. Kambat, Mahi River, Dholera, freshwater. This would be a freshwater design. This would have, the planning, initial planning was this. It would be one of the largest reservoir in the world, in India. So what the idea was, take this water through contour canals, entire along the Kutch area. So the Gulf of Kambat, which establishing a huge freshwater reservoir for irrigation, drinking, and industry. Please, if some of you want to see this, this is a Gujarat government project. It is there already, and geotechnical investigations are being done presently by the government, and Korean government may be helping the Gujarat government to build this dike. But there are also small changes being made. They would like to maintain the tidal basin on one side, only store half of that fresh water. The new ideas are coming in. So gross storage is 16 billion cubic meter water. See, which is a large storage. Okay, 64 kilometer long dike, which will connect Bhavnagar to Bharuch. You know, that's the kind of, which will reduce 400 kilometer distance also. So my concept is what is called a Sarovar Mala. These small reservoirs at every river mouth need not be a second, it could be a second generation coastal reservoir. Connect them through pipelines along the coast, connect them. Then there is a good possibility in the future. I mean, this is a very futuristic. This is not from tomorrow. Maybe 100 years down the road, my next generation or third generation of my people might do this, where we would connect water pipelines to this. Maybe we can start with one or two where there is enough flood water, develop these flood water. So what I'm trying to say is, lastly to conclude, India is not running out of water, but water is really running out of India. Desalination is very expensive and environmentally not sustainable. So cost of coastal reservoir versus alternate water diversion schemes is much, much lower, ladies and gentlemen. I can demonstrate with numbers. We have done some case studies in Karnataka, where we have even developed the feasibility reports to do this. Engagement with community, government agencies, and other stakeholders is a key aspect addressing significant local water issues in the coastal areas. Because as I told you earlier, we have to look at coastal connectivity, that the food, water, and energy nexus, we can solve that using coastal. This is the ISCAR team. What I would like to tell you is how this concept has really attracted top people. You see, Professor Roger Falkland is the past president of IAHR, International Association of Hydro Environmental Research. IWA president, Glenn Diger. And then IWRA president is Professor Xia Jun, Chinese. And Professor Hubert is the International Association of Hydrological Sciences from Netherlands. They are all my vice president. Can you imagine? I'm not even a water resources person. I'm a geotechnical person looking at dam building. And I've done 150 tailing dams and other dams. So mine is a concept. This is a team. They're all excited about pushing the concept of coastal reservoir to many countries. And I want to tell you one news before I conclude, that Malaysia government has actually announced no more inland dams. If they build, they're going to build only coastal reservoir. Similarly, Indonesia is already picked up through our interactions. They're also looking at, because Indonesia is a country which is an earthquake-prone country very heavily. If an internal dam breaks, all the downstream would be in great danger. But if a dam in a coastal area breaks, it will go to ocean. So this is with this few statement. ISCAR is for water, food, and energy nexus. And the solution is downstream water management for water, food, upstream water management for energy, food. And we are having a first world conference in coastal reservoirs. Because of COVID, we have to postpone to 9th to 12th November of 2022, that is next year, in China at Wuhan University. So I hope some of you would be able to join. Thank you. Namaskar.
Okay. Thank you, Professor Sitaram, for your very excellent presentation. In 1972, this interlinking river idea was propagated, the conference which I attended during the year. So congratulations for giving this new revolutionary idea. I have been associated with this sculpture project for 4 years. That was the design that you are now suggesting, second stage or second design. I think it is not included in the present cultural reservoir project. The two questions that used to bother us are the water quality issue, that is incoming water that was not of good quality. Gujarat is a chemical industry state, and most of the water that used to come from Sabarmati, it was already poured there. Now, the other countries, wherever these reservoirs have been constructed, are now, means the report that I had gone through, were indicating this pollution problem on large scale. Tanir Mukham, which you mentioned, is also exhibiting the similar problem. But the problems can be resolved with the second stage. In culture, this may not be possible because it is collecting the water of 4 or 5 rivers. It is not a single river whose mouth can be checked and you can build a dam. You raised the question of how civil engineer is associated with this. The civil engineering, I'm also a civil engineer, but my part is the software part. You build a dam for us and we use this water. Most of the, you can say, downstream of check dams, downstream of these big dams, the work relates to agriculture, distribution, miners, command area development, all these activities. So this opens a new situation. The second stage, coastal reservoirs, as you have rightly
Second
mentioned.
generation. Second generation.
Second generation. Second generation, yes, because you know you are not preventing the whole water and storing it. So there are opportunities. But two major problems that I foresee is siltation. This during floods only, the silt load are very high. As a matter of fact, the Upper Ganga Canal is closed because of the higher silt load. So your reservoir, which you are creating in the, you can say, seabed or at the mouth of the terminal end of the river, this situation may be there. Some solutions will have to be found. So, any questions for Professor Sitaram? No. One last question from me. I understand that a small project was executed with your collaboration somewhere, either Karnataka or Kerala. And seeing that paper, we sanctioned another project from Imprint for one of your collaborators for this Karnataka. What is the, are you aware of the development that have taken place in that particular project?
Yeah. I think the project is going on well with our young people who are part of this project at Suratkal, NIT.
Yeah.
Okay. But as you all know that, it is still in a research scale here in India. Only the Kalpasar is gone to the field. So there was actually a mismatch, or I can say one is pushed by the government in a large scale where there is no research. Okay, the other one is through research and development.
Now
we have putting it through the Karnataka government.
There was Dutch consultancy for last, I think, for more than 10-15 years. 6 very beautiful reports have been prepared on all aspects, but this particular aspect which I mentioned was not taken. Anyway, if there are no other questions, let us thank Professor Sitaram for his excellent presentation. This is really a revolutionary idea, which India, if it is implemented in due course, will be able to ensure water, energy, food security. Thank you very much.
Thank you very much, Professor Sitaram, for your wonderful presentation, a new concept, a second generation, as you call it. Only thing that my concern is that you have put listed certain challenges also, and rightly so. And the ecological sustenance in general should be the top priority in catering to the need and executing this kind of works. But it has been a wonderful concept, no doubt about it, doing away the other concept that we had been nursing for quite some time. So I had come to know about it from Dr. Taggi some time back. So I thought that you must be there to share with us. Thank you very much, Professor Sitaram, and thank you very much, Dr. Taggi, about it. Thank you. Thank you all the best.
Thank you.
Thank you. We close the session, Dr. Burman.
Just a minute. Thank you very much, sir. Now we have another session, Dr. JSP Yadav Best Paper Award presentation. For that session, again, I like to invite Dr. N.K. Taggi to chair this session. Sir, here, actually, our society give this award, that is JSP Yadav Best Paper Award, based on the paper presented in our journal, that is Journal of Indian Society of Coastal Agriculture Research. And this time this award has given to Dr. Muhammad Tariqul Islam and his team. And Dr. Tariqul Islam is the head climate change cell of Institute of Water Modeling, Dhaka, Bangladesh. And this award has given to their team on the topic. The paper title of this paper was the groundwater salinity modeling in the southwest region of Bangladesh, considering the climate change. And this paper was published in the Journal of Indian Society of Coastal Agriculture Research in 2020 in volume number 38 and 2. So we'll invite Dr. Muhammad Tariqul Islam to present this his paper in this particular session of the Dr. JSP Yadav Best Paper Award presentation session. So, and Dr. Taggi, sir, will chair this session. Now I hand over this to Dr. Taggi, Chairman.
Well, you have already introduced the speaker, Mr. Tariqul Islam, the winner of this prestigious JSP Yadav Memorial Award. He holds a master's degree in engineering from Technological University of Bangladesh. His professional career spans over 20 years, and presently, as you mentioned, he is the head of the climate change cell. He specializes in mathematical modeling in hydrology and hydrodynamics using Mike Shih flow on Mike 11. These are internationally established, well used for the hydrology and hydrodynamic studies. I'm very happy that he, in his paper, which is to be presented now, he has used all these three models to present beautiful results from his study. What surprised me when going through his CV was that engineers normally do not consider the social science issues, but he surprisingly is also well versed in the research tools that are mostly used by social scientists, such as rural rapid appraisal, structured interview, semi-structured interview, and this group formal this focus group discussions. So this is another part of his expertise, engineering as well as social sciences. I have great pleasure in inviting you, Dr. Islam, on your paper on groundwater salinity modeling in southern region of Bangladesh. I think some useful information will be coming from it. Thank you, Dr. Islam. Any problem?
Yeah. Hello?
Yes, yes.
Yeah. Okay. The presentations. Yeah, please. Yeah, 1 minute, please. Yeah.
I forgot to mention, Dr. Islam, the time is 20 minutes.
Okay. Yeah. Are you hear me?
Sure.
Yeah. Okay. Respected chairman and dear participants, Assalamu alaikum and good afternoon. Welcome to the presentations on groundwater salinity modeling in the southwest region of Bangladesh, considering the climate change. On behalf of my team members and colleagues, Busramon Duti, Rezaul Hassan, MD Atikur Rahman, and ASM Mahbubur Rahman, ASM Sahabuddin. I am presenting this paper. I Muhammad Tariqul Islam, Head Climate Change Cell Institute of Water Modeling. You know that coastal area of Bangladesh suffers a lot due to different degrees of salinity, in addition to other problems like sea level rise and other natural disasters. And I think the coastal area of West Bengal in India also faces similar types of problems, because nature is not bound to obey the international boundary or man-made administrative boundary. However, the study area covers a part of Khulna districts, Jashore districts, and Satkhira districts, which is situated in the northwest coastal zone of southwest coastal zone of Bangladesh, and the area is about 1,534 square kilometer, and the annual average rainfall is about 1,750 to 2,000 millimeter, and humidity in this area varied from 43 to 86%. And Kubalak River along the west side and Rupsa River flows along the eastern side of this river. In addition to these major rivers, other rivers also flows within through this area. And coastal zone extends about 47,150 square kilometer, covering about 19 districts of Bangladesh, and the coastline is about 710 kilometer length, and the elevations of the coastal area varies from 0 to 3 meter PWD in southwest and south central, and 3 to 5 meter PWD in southeastern, and 12 meter PWD in the eastern hilly region. And seasonal variations of sea level rise is a major issue, and salinity water includes about 70 kilometer inland in southwest coastal boundary, and definitely it's a major problem for this area. And you see, this is a hydrostratigraphic sections of this area, which traverses from north to south. Actually, there are three aquifers, that is upper or composite aquifer, within 50 meter from ground level, consisting mostly of heterogeneous assemblies of sand, silt, and clay, and the lower shallow aquifer, which is unconfined to semi-confined nature and situated within 50 to 150 meter from ground level, and consists of medium sand to coarse sand with occasional fine sand and silt, and deeper aquifer containing fresh water at 220 meter to 350 meter depth, found by Denida Defechi. Under this study, we have confined within up to shallow aquifer due to data limit. We have not gone we have not investigated the deeper aquifer in details. And from different secondary sources, the relevant data, most of the relevant data were collected. And in addition to the data collected from secondary sources, some bore logs, groundwater salinity, surface water salinity, groundwater level were collected by IWM itself, and about 52 observation wells installed for groundwater level and groundwater salinity measurement purpose, and geoelectrical logging were performed at 44 boreholes for groundwater salinity measurement. In order to understand the river aquifer water level interactions, water level recorders were also installed at Batiaghata Upazila in the Kajibacha river and in nearby aquifer for the entire monitoring period from 2012 to 2013. And for this study, MIC, MIC 11 and FFlow modeling tools were used. MIC 11 for flow assessment, for river flow assessment, MIC for groundwater assessment, and FFlow 6.1 was used for simulating the salinity in groundwater and groundwater. In this paper, only free flow modeling has been reviewed in details. Surface water level and flow obtained from MIC 11 was incorporated in free flow model. Calibration and validations were done with the updated data. And for groundwater salinity using free flow, 2D finite element mesh was generated, which was redefined along the river side you see, and the length of the triangles varies from 100 to 250 meter in the riverine side, and for other area it varies from 250 to 500 meter. And hydraulic heads and salinity concentrations from steady state simulation were used as initial condition of transient simulation. And boundary conditions, surface water level and surface water salinity along the river was used for west, east, and south boundary, and groundwater level for north side was used as the boundary conditions. And the major hydraulic parameters that are used in this model are for upper shallow aquifer, the hydraulic conductivity was about 9.4 meter per day, and lower shallow aquifer 20.91 meter per day. And vertical hydraulic conductivity is about 1/10 of horizontal hydraulic conductivity. In addition to this, specific yield and storage coefficients are also used for these modeling tools. And the model have been calibrated both for groundwater level as well as groundwater and salinity. In this figure, you see a calibration plots. The continuous line shows the simulated result, simulated by simulated and groundwater level, and the dotted on is the observed groundwater level. So the calibration is quite good. And this is the calibration against groundwater salinity. This figure shows the observed groundwater salinity, and the right side, the figure shows the simulated groundwater salinity for the year 2013. So if you consider the spatial distributions of groundwater salinity for observed as well as simulated, it is quite good, I think. And the left side, the figure, you see the electrical conductivity for river, upper aquifer, and deeper aquifer. For upper aquifer, the electrical conductivity is higher, and shallow aquifer is comparatively lower. And definitely, it indicates that the salinity the salinity in river water level is quite high than that of groundwater level. And we have also investigated the groundwater salinity in climate change scenario. So what will happen? We have investigated what will happen the groundwater salinity if climate change is happening. And for this option, rainfall, surface water level, and river salinity for the year 2050 has been predicted considering the climate change conditions. And for the remaining period, that is from August 13 to December 49, these data have been estimated by linear interpolations and sea level rise for future conditions, that is for the year 2050 has been adopted from IPCC report. And groundwater abstraction for future demand management considering household, irrigation and industrial demand has been calculated or estimated, and morphological conditions has been considered as of existing, that is present conditions as of 2013. And the result shows that the overall, the groundwater salinity will increase in future, and area under high saline zone, that is the area, the salinity is greater than 2000 ppm, will increase by 14% in 2050. And area under fresh water zone, that is less than 1000 ppm zone, will decrease by about 3.4%. And we have also investigated the groundwater salinity situations along these sections and in this area AB, and this AB. This figure shows the groundwater salinity in 2013 for 2013, and this figure shows the groundwater salinity for 2050. So the area under groundwater salinity range from range less than 1000 ppm will be converted to the area of groundwater salinity greater than 1000 ppm in climate change scenario. And for this area, a number of alternative in this area, a number of alternative technologies are being used. This is for pond sand filter, that is PSF, and this is managed aquifer recharge, MAR, and this is rainwater harvesting. And this type of alternatives should be used in this area, because it will not be a wise decision to abstract groundwater into too much in this area. If it is done, if abstraction is higher, then there is a possibility to introduce saline water more in this area. So a number of reports and papers have been reviewed under this study. These are, thank you.
Thank you very much, Dr. Lam. This is an excellent presentation, which actually deals with the coastal area problem, and he has gone to the field and collected information. More such studies are needed. By way of my queries, what was the size of your grid? You have so many nodes.
The size of it's a triangular grid. The size I have already mentioned that varies from 100 to 500 meter.
100 to 500
meter. Yeah.
And how many such nodes you had?
Number of nodes. This area.
Why I am putting the data on which the averages of these groundwater salinity and levels are arrived at this has to be, there is a statistical procedure to test the adequacy of the data.
Yeah. Actually, if we think about MIC, all grids should be the same size. That is square, say 100 by 100, 1 kilometer by 1 kilometer, or 500 by 500. But in FIFLO, there is a flexibility. You can rearrange or for your targeted or interested area. Yeah, grid size may be smaller.
Issue is you are projecting these things under climate change.
Yeah.
But without climate change also, these you can say salinization takes place. It happens all the time. How do you separate the effect of climate change with and without climate? If there were no climate change, what would have been the situation?
Yeah, actually, if we think about climate change, then definitely there will be sea level rise, and due to for climate change, there will be a change in the flow from upstream, and at the same time, the salinity in river will also be changed.
So what I'm asking is, how do you separate the effect of these two? No climate change and climate change. So what is the contribution of climate change towards this salinization of the groundwater?
It's a difficult question, I think, definitely.
Maybe in your next study, you will try to don't include the effect of climate. What does climate do? It is changing the flow, and then it is raising the water level in the sea level. So both these things have a effect on the salinity. One, okay.
Definitely.
But it is a very good paper, and I wish that this is conducted. These studies are conducted more places. Thank you very much.
Thank you.
Any other question?
Can I raise a question, please?
Sure.
Can I raise a question, please? Dr. Islam, this climate change is one phenomenon which is superimposed on the other factors, as I can guess, which is being superimposed on other factors causing rise of salinity in the soil. Number one, that you have got groundwater salinity to increase. Number two, the factor that has been in fact moving around my mind since morning from a presentation, in a number of areas, the groundwater recession in India has taken place considerably. This is forcing the seawater intrude into the coastal areas by active movement, not by passive movement, by active movement. That is causing further rise of salinity. So I think, do you have any idea about the kind of recession that takes place in your area because of intensive cropping and maybe poor hydrological condition of the surface flowing water in some cases? Do you have any data on the groundwater fluctuation over time, over a long time rather? Do you have any data monitored by not only your group but other groups? But all these things are being superimposed by climate change to have an overall impact, adverse impact on the rise of soil salinity. That's true. But I precisely want to know, do you have any data on the groundwater receding considerably over a long period of study? Anything that you have been able to monitor over time?
Yeah, actually, in connection with a project funded by Bangladesh Climate Change Trust Fund in coastal area, a number of groundwater monitoring wells have been installed in that area during 2010 and 12. So from that period, we have groundwater and level data, sufficient groundwater level data from 2012, to till now.
What are the results?
Yeah, actually, in coastal area, the groundwater abstractions is not so high. Only in the urban area, the groundwater abstractions there is an increased trend of groundwater abstractions in urban area.
Is there any government policy not to allow or minimize at least the groundwater abstraction?
Yeah, of course. We have definitely we have a policy, and for coastal area, especially for coastal area, government from government sides, it is not allowed to over extract in that area groundwater, and government says to for more use of surface water, especially for irrigation and purpose, because for irrigation and purpose about 97 to 8% water is required for irrigation purpose. Only 2 to 3% is required for domestic or other.
You have heard the previous speaker, Dr. Sitaram, also.
Yeah.
He has emphasized so much on surface water storage through a chain of reservoirs or lakes all around the country in India. So something of that kind, and a well-targeted and periodic monitoring is required for that purpose. And simultaneously with this, the groundwater abstraction should be minimized over time.
Yeah.
It cannot be stopped altogether immediately. But
Cannot be stopped, definitely.
Thank you very much.
Thank you.
Yeah.
Okay. So if there are no other questions.
Yes, I do have.
Yeah, please.
This is Sanyal speaking. May I?
हाँ सनियाल साहब सुन रहे हैं आपको.
Dr. Islam.
Yeah, please.
Dr. Islam, am I audible?
Yeah, of course.
You talked about abstracting groundwater mostly from the shallow aquifer down to 50 meters, right?
Yeah.
And we are aware of the reports that about 43 districts out of 64 districts in Bangladesh, particularly the shallow aquifer and the intermediate aquifer, is highly contaminated with arsenic. And do you see any issue related to that as regards the pollution and entry of the pollutant in the food chain? This is a very widely debated issue in Bangladesh and around the globe. Bangladesh is perhaps the most arsenic, groundwater is most contaminated in respect of arsenic in the world. And so when you talk about even in the coastal districts, when you talk about abstracting water from the shallow aquifer, obviously you have to take care of that.
Yeah, definitely. But in coastal area, the arsenic problem is not so high. The major arsenic problem in Bangladesh is Noakhali, Feni, Hatia, and this side. Yeah. But in this side, in coastal area, in southern area, arsenic problem is not so acute. The saline problem is a major problem.
In Borishal district, you do have arsenic problem. Pretty high.
In some places.
We have been working on this issue for a long time, and we have got some collaboration with Bangladesh as well. So we have certain idea as to which districts are affected with arsenic contamination in groundwater.
Yeah, definitely it will be create another hazard. Yeah, if we extract the groundwater, then there is a chance to spread arsenic in groundwater. Thank you.
Any other question? No, then let us thank the speaker. And I also thank the organizers and my close friend Dr. Sain for holding such a nice conference, and to Barman for his excellent job during the conference and before conference. Thank you very much.
Dr. Barman.
Thank you, sir. From behalf of the organizing committee and from the society, I'd like to thank our chairman, sir, for conducting nicely conducting the sessions, 2 sessions, I can say. And as rapporteurs, I am also thankful to rapporteurs and all the participants represented, and many congratulations to Dr. Tariqul Islam and his team for receiving this award, prestigious award, the JSP Yadav Best Paper. Just little bit, one announcement is there. We will start the next plenum lecture at just 6:30 in the same room. So no need to leave this room. Just you stay here and we'll join shortly. Just we'll take the break, but it will be in the same connection and all these things. It will be in the same room. And this lecture will be given by Dr. M.M. Qadir Mircha. He is from the University of Toronto. His talk is a very interesting topic of today's time, that the coastal agriculture and future climate change can develop countries adapt. So we'll start exactly at 6:30. So we'll in the same room, this room. Thank you.
Now it is a break.
Yeah, break for already our speaker has joined the session. Dr. Mircha.
Thank you very much.
Thank you, sir.
Dr. Sanyal?
Yes. How are you?
How are you?
I'm
used to be our frequent visitor.
I'm fine.
Yeah. Fine. Good to know.
How are you and your family, sir?
We are doing well.
You are settled in Karnal or Delhi?
No, I am neither in Karnal nor in Delhi. I'm on the border of Delhi, Ghaziabad.
Oh, Ghaziabad.
NCR.
In UP.
Yeah, good.
We are doing quite well here. I'm now 70 years of age.
70 is no age. I'm 75.
Anyway, very nice hearing